Does it sound better? Let me test here. Let's see. That thing works. All right, I forgot to turn on that part. Sounds good. Oh, thank you. He was doing. Now the thing is, my audio interface here. My audio interface here sometimes, I don't know, I need to select it either as 44 kilohertz or 48 kilohertz input into the computer. And if I set it wrong, either I sound like a chipmunk or I sound like Darth Vader. So, you know, it's just, I should probably always just listen back to what it's recorded. Good. I listened back on Audacity to it and it sounded okay. I should always just do a sound check, I guess. Yep, right. So, has no direction, right? And so that would manifest if I went here. So here's a function that actually turns a direction vector into a heading. And you'll notice, let's see, is it here or where are you? You see if you use geom direction to heading. Where are you? Oh, right, wrong file. Direction to heading, and you'll notice that what would happen here is we do a division by 0, because if it's a 0 length vector, right? So it would be greater or equal to 0, greater or equal to 0. In that case, it would go arcsine of direction x vector divide by the absolute value of a 0 vector, which would be 0, which is divide by 0, and you'd get a very nice undefined result out of that. The output would be a nan value, which is not good. So instead, what we do, we just give it a 0, so north direction, 0 wind speed, whatever. Just call it a day. Hey, Pilsnerish. Yep, I'm back. Hopefully. Mostly anyway. Okay, so this interpolates the wind component. Good. And let's see. Actually, we'll break out of here. If we have a temperature, if the caller requested a temperature, then we'll interpolate the temperature for them. We will make this, this is going to be pulled out of here, over here. And this is the mixing ratio. Blah, blah, blah. Okay, so if we have a ratio there, actually we could just return here, just be done with it. In that case, when we get here, we know that we have searched and not found anything. Good stuff. Okay, so in that case, if they want a temperature from us, we'll go ahead and set the temperature to the weighted average of let's see, am I using clamped values? Yes, I am. Could I be? Yeah, sure. Weighted average of GFSI T, GFSI plus 1 T mixed in the ratio. If T dew point is requested, that case we'll give them the dew point, dew point, good stuff. And so here, when we get here, this is basically we've searched and they've passed in an altitude for which we do not have data. Now this shouldn't happen, but in case it does happen, we want to handle it, of course. The wind direction is not null and wind speed is not null. In that case, we'll want to give them the last entry that we have for wind direction and wind speed. So that'll be wind direction is the last thing there, and wind speed is the last thing that we have data for. If they have requested a temperature, give them the last temperature we have in the data set. T, and same thing for dew point. DP, good stuff. Hey, Pancake King, you got your popcorn. Good stuff. Important. Always, when I'm coding, always important to got your popcorn ready. Okay, so this now we have re-implemented in common. Good stuff. So what is it that I want to code in here? Right. So extract wind al wind winds aloft data. Good stuff. Okay, so we want to extract 18,000, 24, 30, 44, 39, and 45,000 feet. So just make it a static const altitudes, and so I don't have to hard code anything like this. So feet to meters, we want an 18,000 feet entry. We want 6 entries, in fact. 24, 30, 34, 39, and 45. And make sure I didn't miss any of them. We'll make a compile time assertion here. Array num elements altitudes is equal to num winds aloft. So CT assert is a compile time assertion. That basically means it's a constant assertion. It doesn't, when it's in release, is going to have to install explain again. Well, hopefully. Smuggler. So it's a compile time assertion that only is run when, or it doesn't execute at runtime. Rather, it's done at compile time before any code is generated. So basically that checks for, you know, for example, when I change this value here for some reason, and I forgot to enter more winds here, that'll basically stop the compile here with an error saying, you know, this assertion is not true, you know, you want to check it. Hey, Sneaky Danish, how are you doing? Okay, so for int I is less than num winds aloft, I++, and I'll want to extract wind direction, wind speed, and temperature. Got a piece of hair in my mouth somehow. Anyway, I'm talking way too much. Good. Good, so wind direction, wind speed, blah, blah, blah. GFS interpolate. Okay, GFS interpolate, GFS, and GFS. And so altitudes, I, and we'll still give it wind direction, wind speed, and temperature, and we don't want the dew point. We don't care about the dew point. Okay, with that in hand, we can go ahead and append a line on there. There we go, append format fixed. Actually, no, it's not append format fixed. Rather, it's, I already have it broken up into lines. So all I gotta do now is winds aloft lines I, size off winds aloft lines I, and we'll put in, so this is 6, that'll be like a 7 character, 7.0 F, space, 0.30 F. So this is basically making sure, the formatting here is what basically makes sure to enter or emit enough leading spaces. In the case of the altitudes here, we want to have them 7 characters wide, so they'll take up that amount of space, and there can be 2 spaces. Hey, Jono Livingstone Seagull, welcome, welcome. Then 03 means it's going to be 3 characters wide, no decimal point or nothing following after the decimal point, and leading 0 means that if it's like 50, then it'll be 050. Okay, and then we'll make this 1, 2, 3, 4, 4.0 F. This will be knots, and then 1, 2, couple spaces, 3.0 F. Good. Good stuff. So first of all, altitudes I, but this is now in meters, so meters to feet needs to be in feet. Then wind direction, meters per second to knots, wind speed, and Kelvin to Celsius, temperature. Switch over HFDL. I'm just reading Discord here. Yeah, that'd be fun. You get 2.5 frames by the time you cross the Atlantic. Yeah, probably. Or like 1 frame. If that, hopefully. Depending on the speed. Good stuff. So we have our wind data constructed. Good. So let's see if this compiles. I don't actually have currently anything to display it. Actually, let's compile a little bit faster. Okay, there we go. Didn't take long to get to first error. Okay, GFS parse, right. Phys.c 640, and I don't want the current time. Okay, common GFS. So PL21 common GFS.c. And the first mistake. Okay, I probably forgot a closing brace somewhere. No, I didn't. Hang on. Access elements and initializer. What are you talking about? There's 12 items here, 12 things there. All right, it's a char. Yeah, that'll do it. 52. It doesn't know about LACF time GM, which is obvious because I haven't included the header for it. So now you should know about it. Parse date time, implicit declaration of function. Parse, yeah, parse when. Parse when. 116. This is end data. And instead of GFS, this is going to be called data. There's extra space here. And wedding photo shoot from yesterday, watching the stream. Oh, cool. Neat. Okay, iterate fraction. Right, you probably need math.h for that. And 147. And GFS will be end data. Good stuff. So we've progressed a little bit. Flight plan wind update. Okay, CMU FPL CMU subsystem flight plan wind update TO4. Yeah, you want to pass in a null here because you don't care about when the observation was done. All right, here we're getting into the actual meat and potatoes of what we've been working on. Okay, 520. Track wind data. Right, you probably need to include common GFS.h. Okay, 524. You probably need a type. 542 has no member named lines. Right, you probably need named you something different. CMU subsystem weather implementation. You call you lines, sure. Okay, 555. When aloft current waypoint is less than downwind AL. What did I call you? Right, winds aloft current waypoint. I'll take care of a lot of them, right? What? 565. Cancel winds aloft. Cancel request. It's noun then verb, not the other way around. 578. You get down. Let's say right. I didn't handle some of them. So in that case, I don't care about all the others. And there we go. Now it's happy. Now This unfortunately doesn't show anything currently because that's just the gathering engine. But we also need to write the front end here. So we need to write this part. And for that, we'll grab a prototype here, CMU subsystems, wins aloft request. That's the view part. We want to go to the request part. There you are. Wins aloft request. CMU subsystem wins aloft request. So this is going to be the thing that actually draws the output here. Wins aloft request. Wins aloft request. I call them all subsystems. So this isn't sitting. The reason why this is called a CMU is because the communications management unit. The data here is not gathered by the flight management computer. The data is gathered by the communications management unit, which is a separate box, a separate computer, and your CDU. The speed at which you fix build bugs, I'm constantly amazed. When you've seen so many of them, I guess. This kind of becomes second nature. This doesn't need any state. So the communications management unit is a separate computer. Your CDU can connect to that CMU, to the communications management unit. And the CMU is much like the flight management computer in that it has its own set of functions and its own set of menus and everything in there. It looks like you're just interacting with the box, but the box actually is talking to a completely different box than the box that you're used to. Okay, so win aloft request key. So this is handling key input. That's your first do draw part. That's fun. Wins aloft request draw. We don't need the data part. We do need CMU get subsystem data. CMU subsystem weather. WEX, and you also want to grab its definition. So CMU subsystem WEX impl.h. Good stuff. So this is going to be left aligned. It says DL11123 dash request wins aloft. I know it doesn't show a dash here, but there is in reality. I can tell you that. This manual has, this is a real manual, the official stuff. This thing is, let's just say it has some variations from reality. Quite a few, actually. So, yeah, I have to basically sort of compare with the real aircraft to frequently, work out where the kinks are. CMU subsystem, actually, I'm going to copy a piece of a subsystem here because this is a case where I'm doing a little bit of copying left and right. Captain Zach J236, thanks for the follow. Welcome aboard. Unexplained, I think I might accidentally press something on the developer bar. It will affect all my Perryware plugins. I'm pretty sure that rather doctrine wrong. He's at 11. Captain Zach J236 depends on what plugin, what payware aircraft. Worst case you can do, or worst case just restart the simulator and you should be good. But there really isn't much that you should be able to do there to break stuff. Okay, so this is the part that I basically want to copy, but with variations left and right and everywhere. Okay, get rid of this. Request wins aloft. Okay, so CMU terminal weather is a request. No. This will be CMU wins aloft is requested, or rather, I also want to implement that. CMU subsystem weather, blah, blah, blah. And we want to put in a new one here, wins aloft. This is another case of this where you need to just write a truckload of code before you are ever able to even, get anything working. So we'll want another test function, set of test functions here. So this is for printing various little status messages all over the CDU where it could break my pairware plugins or aircraft. Well, I mean, you could break your payware aircraft, not even launching the simulator, but deleting half of them or pieces of them or something. I don't know. Developer bar, generally it shouldn't break anything, but you know, whatever. Why would you want to go in there? Anyway, I mean, you can, of course, if you want to play around, have fun. Okay, wins aloft request, wins aloft received. I think I have a, I think I have a, yep, a boolean like that in place. Or CMU wins aloft is requested. Or CMU wins aloft is received. Good stuff, good stuff. And also for CMU 4000H, there's going to be 4 of these. Wins aloft request, wins aloft view, wins aloft call you waypoint. There's going to be 3 more. Where are you? There you are. Okay, so terminal weather. I'm just going to do a bulk rename here because that'll take forever. Okay, and terminal weather winds aloft. No. Winds aloft. Good stuff. Then come in here. Gonna be up here, and you're gonna be winds aloft. Winds aloft. And it's not an airport, but it's waypoint. You're gonna go to the end there. Not airport, waypoint. I should set a live stream channel allow notifications. Hey, IntelliFX. Possible to make a sim brief uplink BX plane yet? Yes. Smallgren, yes. I've already got that implemented. In fact, I should probably just show you, but currently, actually, I do have a functional build. So, yeah, I do have a functional build. It won't fetch winds aloft, but you'll see. First plane ever an X plane? No, I think the INI A300 already has that. Okay. Hopefully that didn't blow your ears out. Yeah, about there. Good stuff. And we'll cancel you. I'm gonna pull the window down a little bit so we have it better matched up. Okay, close enough. I need to connect ground power. I didn't have that, or rather when I reloaded with the state here. All the CD accepted a message line blank. Oh, that's because this guy thinks he's still connected to the datalink system. So currently it's sitting on the datalink status page. If I go back there, it won't let me anymore. It'll kick me back out. So if I go like this and now power up, there we go. So that's what the thing was. Who makes the sim brief profiles? Where the profile doesn't match the sim plane. So I don't know. Currently, I don't really care for that. I'll mess around with that a little bit later. Yes, I do have a flight plan here from Orlando to Key West. You can edit profiles. Yes, you can. How about I'm lazy? Well then. And so all of these are now functional. Well, this button isn't here. I can generate little clock chimes. If the FMS was offline, I could set my own clock and date inside of the CMU. Satellite data link currently isn't simulated, so that'll be coming later. VHF data link is. Thing is currently sitting in scan mode, so it's basically scanning through all the frequencies available, checking to see what stations are online. So currently we're running over VHF. Person who ran SimBrief makes them, I assume, yeah. Right, so this is where you'd set your user ID for SimBrief. Normally this would be filled with data for like system configuration, hardware configuration, and mostly basically just static data. So I basically repurposed that page for viewing. So it'd be lines like these. I've repurposed that function for setting up your SimBrief linking. All it needs is your pilot profile, which you can actually find underneath when you plan your flight. It'll say pilot ID there. So all you got to do is copy that number. Then when we go to, we go to index, route menu. Do I have a flight plan in there currently? I do, but yeah, so I do have two different flight plans in there. You'll notice you'll see what it looks like when we get a flight plan recall. So this is how you downlink a flight plan. Hyphen does look out of place. Yes, I know, but that's the way it is in the real thing. It really does say this. Can't you also just enter time into the status page directly if you don't have GPS time? Yeah, so here's a trick. This is the flight management computer you're talking right now, whereas this is the communications management unit. There's a different subsystem that you're connected to. So the data link time and date that you see here, if we go to technical clock set, this time and date is a separate internal clock simulated inside of the CMU, whereas the stuff you see here on status, that is the FMC internal clock. Now, when the FMC is operating, it sends out via airing 429 little updates. Go to LFMC1 here. You'll see that it sends out, if we go over here, look at this here, FMC label 0125 Unix time, and you'll see that it sends out the current system clock status internally. And so that's what the CMU normally listens to. That's what it syncs up to automatically. However, if the FMCs should not be available or not be sending out the data, which we can simulate by just literally pulling power on them. So I'll kill FMC1 and FMC2. You'll see now they go into set time and date because it's lost the inputs from the FMC. Now I can set whatever time I want in there. So I'll set it to 2000 hours and a date of, I don't know, 20th of October 2020. Sure, why not? And you'll notice it still runs all on its own. And now this is FMC3. It doesn't when I killed both of these breakers, I actually killed some interlink infrastructure, which prevents FMC3. It normally receives date and time from FMC3 as well, but I've killed some interlink infrastructure as well that gets the data over to the CMU. So now the CMU cannot even see FMC3 inputs. And so you'll notice now they are running independent of each other in times of clock and date. Now when I boot them back up, it'll take a couple seconds. There we go. So it's reacquired the input from the FMC. I've got it actually right now set to go a little bit faster on the booting. The FMCs take a couple more seconds to boot up in reality. Another thing you might have noticed is that when I pull this guy, the FMS message should go away. There. But only on CDU1. Because I've basically killed FMC1, but FMC2 is still functional. So this guy still has message info. And if I reboot it back in, there we go, message is back up again. FMC1 has booted back up. And you can even see it over if you go to peripherals. If I go and kill FMC1. Also kills IAPS2, which is a separate piece of interlink infrastructure, so kills that linkage as well. What happens if you try and go to the Lex page with FMCs off? Nothing. FMS not responding. What you're gonna get there. This guy here is currently functional. If I kill him, it'll make the page go blank. And if I try and access it again, it'll basically say FMS not responding. Or hang on, I might need to change pages here. Or maybe exit out of the subsystem here. Oh no, right, I gotta exit out of the subsystem and try and re-enter it. That's when it actually notices that the connection is dead. So, like that. Yeah, right. You want to go and get your power back on. It's been soon. We'll have a field day. Yeah, field month. Anyway, so data link. Well, what do we want to check here? Right, we want to grab. Another thing you'll notice if we go to flight plan recall, if the CMU wasn't operating, you'd get you would get this page. So this page right now is generated by the FMC, but it then sends all the requests for flight plans over to the CMU. And if the CMU ain't responding, you're never going to get a flight plane out of this thing. Hopefully make it clear, people, that FMS is a lot more than the CDU. Yeah, there's a whole network of computers. This guy is wired up to an avionics closet back here, and there's a whole bunch of cards in them that do various stuff. And CMU actually isn't even part of the IAPS card cage. It sits outside of that, the separate box, literally. Anyway, so the way you can make your request here is you can either enter your origin and destination. And by the way, it doesn't check for what you entered here, so I could literally go say ABCD, and all that would have. Is there a way to get METARs? Yes. Yep. I'll show it all to you. Don't worry. So Key West. I could make a request like this, or I could enter the tail number of the aircraft. So in my case, let's see, go out of like that. So my tail number, so normally what you'd enter here is the flight plan number. That's a thing that's a thing inside of the inside of whatever corporate flight plan management system you have. In my case, I've simulated it by basically making you enter the tail number of your aircraft that you're going to be flying there. So that basically you are simulating the server side of your corporate data link, sorting through all the flight plans that your company has, and it basically picks out the latest one that you have for said aircraft. And so your tail number would be, let's see, are you noted in here somewhere? It would be in, if we go to, I go to my fleet, yeah. In my case, I have a Challenger. Where are you? Oh yeah, there you are. CL650, and it is whatever you have entered into your FIN number here. So it's basically matching up this. So FIN, not the registration, but the FIN number. If it is letters, it'll also let you enter those. So if, let's say your tail number was letter based rather than number based, it'll let you do that. If it was there at the top middle first line. Oh, gotcha. Okay, well, let's have a look at my briefing. Top middle. Air block. CL650. The tail number itself, yeah. So it's whatever you enter as your FIN number. It can be probably found in here somewhere, or you just know, whatever you've entered in there. So in my case, I've entered 650. If you want to, you can enter as your FIN number your whole registration, in which case you would enter November 650 Charlie Lima in here. But it is limited to 6 characters max. So if I try and enter too much in there, it'll trim it to 6 characters. So that's that. So I got to enter my FIN number here. or origin and destination. That's also a way to do it. And so now I hit send, and now we just wait. And we wait, and we wait. And it's actually not going to beep at us. Downlink flight plan loaded. And it loads it into your secondary flight plan. You'll see now I have Orlando to Key West. It has entered the en route portion. It doesn't downlink the SID and star because that's not part of the flight plan according to SimBrief. At least SimBrief doesn't provide it in the flight plan data. But also, in reality, ACARS doesn't downlink a SID and star. You'd have to select those manually. So Orlando, Key West, and then you go to depart and arrive. Depart, and you'd select your runway and your departure. But notice that this is still in the secondary flight plan. To actually make it active, you go to activate. Makes up your modified flight plan. And you can now go into KMCO depart, and you'd select whatever, your departures and whatever. Execute, and now it is your active flight plan. Now you'll be flying it. Did I actually accidentally select something that actually works? Apparently I did. Cool. And we could even review that. So go to MFD, 2-waypoint. I don't know, whatever the hell I punched in there. Give the ICAS over to the other guy so we can actually get full screen there. And we could, I don't know, mess around with it. There's a vectoring leg in there somewhere. Yeah, okay, so 600 vectors and then whatever. Yeah, so there's a vectoring leg that goes off into infinity essentially, and then there's a portion, whatever. So, initially no wind fetching. CBD systems, that's because the wind comes in the next phase. Because first you got to make your route active. You got to, so it'll load it into the secondary flight plan, you activate it, and when you're happy with it, you execute the change, and then you go to flight plan wind update. Now you'll notice that there's no other entries in here that you got to do. So all you got to do now is just hit send, and you wait. Now you got to wait for quite a while, actually. Or if you don't want to be waiting, you can just hit cancel. But you got to wait for quite a while, and I'm going to show you why. Because for each of the waypoints here, it is fetching GFS wind data, and depending on the number of waypoints, that can actually take quite a while, because we can actually see the thing functioning. If I bring it up here, CL650 debug RSS CMU1 VHF data link. Right now, so this is currently, I'm at Hawaii, so the currently locked on station for my data link is OGG. It's a 10 watt transmitter, and it's like, less than a mile away, so it's at minus 57 dB signal intensity. That's really powerful. And you go to the other pages and enter information while it's downloading. Yes, you can. Yeah, you can just hit request. You can now watch the thing start fetching data here over the data link. And now you can just go ahead and, mess around with whatever the hell you want. And when it's done, it'll pop up a modified flight plan, and we'll see what happens. We can, in fact, even go to data link and watch the VHF in progress flash here whenever it's sending out data to fetch. And then receive, so VHF in prog flashes when it's transmitting stuff, and when it's receiving stuff, it's basically just quiet there. So yeah, you can mess around with it. You can play around. You could go to your perf-init, enter your performance information. In fact, you should probably enter your flight altitude first, because right now it's fetching for a default altitude of flight level 350, which means that the wind information, do you have fixed info in this plane? Yes, you do. There we go. Downlink wind's updated. So we can go ahead and you'll see that there's a message there. And if I'm happy with it, I can just hit execute and the message goes away. Or I could go to here, the leg winds, and review them. You'll see some legs do not have winds on them because these guys do not have a definite waypoint. They don't actually, the FMS doesn't know where these are located. This is an altitude terminated leg and this is a manually terminated leg. So there is no specific point on the leg where it can fetch winds from. For all the ones that do have a definite location, UK, D-Danny, or anything that is a database fix, a database waypoint, it can fetch wind data for. Good stuff. Does it have fix info? Yes, it does. Here, all your standard issue fix info you'd ever ask for. So if you want to say, let's see, bring up this guy. What's a VOR near there? AMCO. Melbourne, MLB, sure. So we'll go fix reference MLB. And instead of direct, we'll say we want a 10-mile ring around it. Distance crossing. And there you go. We'll get a fix. And it even computes where it's going to intersect our flight plan. Or you could go to the standard issue thing of doing it in a beam reference. Also supports that. Or you could do a latitude cross, longitude cross, time offset. You know, I want to see where am I going to be? Where am I going to be 1 minute after? Or hang on. Beam MLB. Might be too little time or whatever. No intersection. Whatever. Anyway, what does latitude crossing do? Well, whenever you're going to cross a line of latitude here on your flight plan, that's where it's going to put the fix. So let's see. What's a line of latitude we're definitely going to cross? So let's say north 27. So north 27. And we're going to cross it over here near Jocks. So go next. And it's right there. Fix or north 27 and 10.0. That's over there. Now it computes a distance to the fix of 4,238 nautical miles because I'm currently located not anywhere near Orlando. I'm currently located in Honolulu or on Hawaii. So it basically thinks that I'm first going to fly to Orlando and then going to fly the rest of the flight plan up to there. Well, there's debug views. Yes, they will. Yeah, they will be there. This gets a lot busier when I'm in flight. Currently, I'm sitting on the ground, so there's really not that much to look at. But we can zoom out and watch, for example, the terrain profile to the other stations nearby. There'll be Molokai. There's a bunch of rocks in the way. Then there's Honolulu. That's a 40-watt transmitting station. And you can see that the curvature of the Earth is starting to get kind of important there. ITO. That's over on Hawaii Island, right here. And again, a bunch of rocks in the way. And you can see that the signal intensities are proportionally low. You know your logarithmic units. Our current signal level is minus 57 dB, minus 166 dB to the COA station. And obviously there's a big rock in the way and the curvature of the Earth. So this is, let me do some quick math. How much quieter is that station? So it's, actually I'm going to use Wolfram Alpha for that. It's a minus 166 dB. 166 minus 57. It's 109 dBs quieter. So it's 10 to the power of 10.9 times quieter. plus equals increased range. What? I don't understand, Captain Crash. No, it's more negative. It's minus 166 versus minus 57, so this is less powerful. And it's in fact by 10 orders of magnitude, almost 11 orders of magnitude quieter, the COS station versus the OGG station. Where OGG is just, less than a mile away from us. It's only a 10-watt transmitter, so this is basically what's called a on-airport transmitter. You're talking about map scale. All right. I'm talking about plus increased range. I can reverse it, really, I don't care. All right, I see. Plus to zoom out. Yes, CBD systems, that's exactly why, because for each of these transmitters, I'm simulating, when you look at your typical airport tower, the thing ain't exactly on the ground. So yeah, your transmitter will be sitting somewhere up here near the top of the tower. So I do simulate varying mast heights. Now, I don't have, obviously, per airport mast height information, but I'm basically simulating it based on type of transmitter. So a low power transmitter, like a 10-watt transmitter, I'm going to simulate that it's, I think, 50 meters above ground level. So this is about 50 meters above ground level right here. Honolulu, which is an en route transmitter, it's a 40-watt transmitter. That guy's fairly far away, but I think that one we can actually check. Let's see. PL21 RSS VHF 4000, and here we go, mast heights. For an en route transmitter, we are putting it 80 meters above ground level. Or you want it in feet, 260 feet above ground level, which honestly is pretty typical of large en route, large airport towers. A typical large airport tower will be between 60 to 90 meters tall, more like 70 to 90 meters tall, thereabouts. And mind you, this thing, the transmitter itself is not at the top of the ceiling of the tower. It's actually on a little antenna up top, a little bit even further out. So these are sort of orientational, but thereabouts. So en route transmitters are fairly far away from the ground. Still, minus 198 dB. This is basically inaudible. This is basically below below noise level. The noise floor, it kind of varies, but it's typically in the VHF spectrum. It's going to be somewhere about minus 110 to minus 120 dB. Or anything below minus 110 to minus 120, you're talking about communicating essentially, below the noise floor. Yes, please, 14. Thank you. So that is kind of not really something you can use. There are systems that can communicate below the noise floor, but you're talking at that point, bit rates of essentially tens of bits per second. Does this handle all the deep valleys where, for example, close station is not available like low? Yes, exactly, CBD systems, it does. It exactly does. In fact, let's see. What's an airport that's reasonably... no. We want something that has a hill in front of it, but whatever. Yes, it absolutely does simulate that. So, for instance, both of these are 10-watt transmitters. This guy's 105 nautical miles away. This guy's 175 nautical miles away. So they're same power, but this guy's 50% further away, more than 50% further away, and yet he is minus 191 versus minus 198. So this guy's even 7 dBs quieter than this. And the reason for that is because in between him and us, there's essentially less tall terrain, less of these sort of peaks. Well, in this case, the problem is that this peak is really, really close by. So we're probably getting even more terrain masking. Now there's The mathematics library that I'm using to simulate this is called ITM, the irregular terrain model. ITM does account for tropospheric scattering, so it does understand that certain signals, especially low frequency VHF, below 100 megahertz, or around 100 megahertz, whatever, they are going to get a fair amount of scatter off the troposphere and the ionosphere. Still, even though they're VHF, there's some amount that does get scattered away. It's not like, super high frequency UHF in the several gigahertz, which basically just punches right through the ionosphere and doesn't really do very much. These guys still do get some amount of data, some amount of transmission, even around the planet. So it's not 100% line of sight. So for example, Molokai here, now this guy, in this case, we've got a lot of terrain in the middle there. But if this was more or less smooth terrain, it's only 40 miles away. If this was just smooth terrain, with maybe a little bit of hills here, even though we didn't have direct line of sight, it would still provide some amount of indirect refraction of both tropospheric scattering, and it actually, even the ITM model understands knife edge diffraction. So if you know signal theory, oh, thank you. If you know signal processing theory, oh, even got a glass of water. Thank you. So if you know your signal processing theory, you'll know that, busy with RadNav for my ATPL and all this makes sense to me now. 2 months ago, I would have been lost. Yeah, so radio signals can actually bend around objects. That the reason for that is basically, how far do you want to go down a rabbit hole of quantum mechanics? But essentially, it has to do with when the size of the knife edge here around which it's bending is close enough to the wavelength of the signal, it'll actually sort of, make a turn round a corner. It'll be significantly attenuated, but it will be there. So that's why, we can, well, in this case, we've got very little signal being received. In fact, it's 30 dBs probably below noise floor. But it's possible. 17 days, yeehaw. Yeah. Okay, yeah. Anyway. I can actually go to somewhere where there's a few more transmitters we can hear. So I'm going to hop over to Orlando. Or whatever. I'm going to hop it over to Orlando. And that way, we should be able to see what it looks like when we're basically on a flat plane. Florida being, fairly flat. Knock on the bridge door before opening, just in case there's a salad dressing. Okay, get the external generator powered up. You'll see what it looks like when it goes through a scan cycle here. Oh no, wrong window. I want to grab RSS CMU data link. Currently the CMU is offline because we don't have AC power on the aircraft. The CMU is only AC powered. Well, it's not. No, it's DC powered, but it's running off a bus that normally is disconnected when on the ground and not on AC power. There we go. External generator is online or available. And here you go. So there's a few more transmitters. So here's a trick. This display changes based on what stations are available and what stations the radio is tuned to. This is a debug display of reality, and this is basically what the radio is seeing here. So currently, we have a VDL mode 2 station here at Orlando. That's why it was blue. Currently, it's scanning through all the frequencies. So the radio is set up. We're making simple HUD for the external power and such. Yes, Mulgren, don't worry about it. There will be a way to activate it without having to rummage it around in the menus. You can kind of see the outline of Florida. Yeah, you can. You kind of can. Yes. You fetch the stations every time the aircraft's being started, or when are they hard coded and then they're somewhere? So it's somewhat hard coded. At least not. It's somewhat hard coded in that there are about 1,200 ACARS stations all over the world, and there's something like 600 VDL Mode 2 stations. So these are two separate systems. The VDL Mode 2 stations I've basically figured out of various sources where they are located. And for ACARS, or the VDL Mode Alpha analog stations, I basically generate them dynamically based on some navigational database stuff. So basically, if the airport is large enough, so to speak, to actually make sense to have a local ACARS VHF station there, because they might go to maintenance from time to time. Right. Yeah, I don't have live status for that CBD systems. It would be nice if I could get it, but unfortunately, reality is such that it's not possible to get it into a nicely sorted global database. Okay, so it's selected a station and it's locked into VDL Mode Alpha Orlando SITA provider. So there are two primary, I'd say two large systems or data link systems providers in the US, or in fact worldwide. There's CETA or SITA and ARINC. Currently, I'm simulating or having it set up in such a way that it prefers the SITA stations, because there's a few more of those around the world. But it really depends on who your data link providers or whom you've got your contracts with. The aircraft, it's sort of like a phone service provider, in that the aircraft will roam to a foreign provider, which in this case would be ARINC. If there's nothing else available, it will hop onto the ARINC network and use that. But if there is CETA available, it will prefer to use CETA, even if it has to run at the VDL Mode A speeds of 2.4 kilobits per second, blazing speed, or if it can get VDL Mode 2, it will use that. VDL Mode 2 is, by the way, about 30 kilobits per second, so it's a lot faster. So currently it is in POA COM ATN no link. That means no VDL Mode 2 link. ACARS is currently operating in the analog Mode A system. CETA North America, 36.8 megahertz tuning frequency right now on the data mode radio, which you can normally only see here as data. But yeah, that's what the radio is tuned to. And yes, you can see the outline of Florida. At Orlando, we have, I think, a 40-watt transmitter, so that's an en route transmitter, high power. And we are currently very close to the ground. But these are the station beacons that we are receiving. You'll see that when it goes gray, that means the station beacon is more than 90 seconds old. That is because this guy was received on a different frequency, 136.87. And it's provided by the ARINC network, the data service provider. And it's a type VDL Mode 2 transmitter. And normally the thing has two frequencies. It normally has a link frequency where it does receive and transmit for data, and then it has a scan frequency. So it basically also listens on another frequency where it listens in for a while to see what sort of station beacons it can see running over the air, and then basically generates a list of stations that are available for it to tune to. There's a complicated algorithm here that basically tries to pick out the best station according to a number of criteria. So, is it my preferred data provider? What's the signal intensity? Is it below a certain threshold? Can I retune to a different station that might be better integrity, give us, prevent a loss of data link? And yeah, if you're outside of VDL or VHF coverage, you might go to no comm here on the data link system, where it's just, you're not going to get any data. And that is also simulated. So when I go to, I've already got the flight plan in there, but we can do, a flight plan wind update, and you'll see that when I do a wind update here, it starts transmitting and receiving packets over the network. Basically, this is simulating us sending out a request for wind information at, or yeah, the wind information at a given waypoint, and then this is receiving the request from our company's ACAR server. Orlando is a little bit quiet there, minus 99 dB, so that guy's, or no, ORL, what are you? Orlando is MCO, ORL, I have no idea what that station is. Oh, it's probably a different ORL. Whatever. No, we just got another beacon. At fairly low signal intensities, getting a beacon out of a station, a usable beacon out of the station. Beacons being basically just short messages where the station announces itself, its presence, that, hey, I'm here, I exist. Interesting that we got so little signal. 8 miles away, we've got straight line of sight. Whatever. Cool. So I showed you. Okay, so it's now asking to execute the flight plan modification because it's uploaded the winds. Now I can go ahead and cancel that modification. Cool. So that is there. What was the other? Right. I think it was. Who was it I asked about whether we can get METARs? Yes, we can. In fact, I implemented that yesterday. So go to datalink and weather, terminal weather, and what terminal weather should we fetch? We could fetch Orlando. We can fetch Heathrow, Key West, Frankfurt. Sure, why not? Send a request. You'll see that we've got all these currently pending, so they're being processed. AORD. Okay, no problem. You can go here, hit cancel. ORD. Throw in there as well. Any other takers? Any other stations that you guys are interested in? No other stations. LIBV. Never heard of that. Sure, let's go. Yeah, PDX. You want PDX? Okay, I'll throw it in there. I only got room for six of them in here, so we'll go. But take Key West out of there. You can actually, you can obviously make more requests, but it would just it takes time because you can see it's currently running full tilt, and it's fetching them, and it fetches multiple pieces of information. So that's why you can see VHF in Prague here several times displayed. In fact, you want to see what it looks like in real time. Let's start the timer at the same time. So go ahead and send and start a timer. Not yet, currently. Yeah, CBD system. Graphical weather, I think, is uplinked into here, but I haven't really messed with it yet. So 20 seconds, still requesting. Obviously, when there's less airports in there, it takes a little bit less time. 30 seconds. $40 seconds. And it's still downloading. And as fast as it can. And this link, by the way, it's because we're on the ground. If we weren't, it'd probably go, half the speed. There we go. About a minute to fetch 6 airports. So we'll go to weather here. We've received the reports. Does the CL650 have a weather radar? Yes, it does. Orlando. So you got your METAR, you got your TAF. Then you've got PyReps. You got pages and pages of PyReps. Normally there'd also be a NOTAM section here. Not sure I'm going to be able to get NOTAMs. global NOTAM data is a little bit difficult to get your hands at. I'll try. Heathrow, obviously no PIREPs because the FAA does not record PIREPs for non-FAA airports. So here you gotta get METAR and TAF. PDX, what's your weather there? Variable 5, 10 miles, broken 1500, 1812. Altimeter, then we got your TAF. No PIREPs. Nobody reporting anything at PDX. PDDF. Obviously no PIREPs there. O'Hare. Apparently nobody reporting anything there. ORD. LIBV. What's blowing BLU? What the hell's U? This is some sort of a strange METAR format. Oh, it's in the remarks part, so it's probably something local or some weird METAR stuff that no pilot really cares about. Glack74, thanks for the follow. Welcome aboard. Anyway, getting back to here. Orlando did have pilot reports, so we can read some of those. Sort of a ceiling and visibility. Okay, I see. Okay, so Orlando has scatter 2200, scatter 12,000, scatter broken 19,000. So not too bad weather. TAF says there's going to be some showers, thunderstorms and rain, showers. Yeah, typical Florida weather. It'll turn on a dime. We've got some PIREPs. Now you'll notice the PIREP here is not for MCO, it's for SFB airport, KSFB. The way that the PIREP reporting or the PIREP gathering function works is it fetches the airport plus a 30-mile ring around the airport. So any PIREP that happens within 30 miles we consider to be terminal weather for that airport because it might affect your approach decisions. So here we got somebody reporting a normal report at time 0004. Why did we fetch? We shouldn't have fetched the one that's so far back. No, hang on. Here's time 1527. This right. So this is SFB VOR 0904 miles away. I think it's the location. Yeah. And then for runway 18 right, time 1508, which would be. This is 18. Yeah, 17, 16. It's about an hour old. This is about 30 minutes old. And yeah, if you want to read pilot reports, you can go ahead and do that as well. You'll have to learn how to read them. So, if you want, I can show you at least some of them, that I know of. This will be a location of the report, time of the report, aircraft altitude of the altitude of the phenomenon being reported. So flight level 008 would be 800 feet. Type SR20 reported a sky condition of broken at 800 feet. They'll basically report, probably being asked to report when they break out of IFR conditions on an approach here. Let's see, I can show you what something like, let's go to fetch Teterboro. By the way, when you delete, that's a bug I gotta fix. Okay, let's go ahead and fix you right away. Oh, no, hang on, we'll have to do some stuff to get that out of there. No, never mind. It wouldn't compile right now because I've got stuff working in progress. Yep. Anyway, terminal weather request. Valid ICAO code. No, hang on. Right now I want to change this. Let's make it like so you can see. else if I want to grab you out of here. Station location, target position. Okay, so station. There we go. Okay, fetch is complete. So Teterboro, any pod reports there. I love it. In the New York area, apparently they like to word out some remarks for pilot reports. So here we have one at HPN. KHPN time about an hour ago. At 2,500 feet. Type Cessna 510. Remarks reported bases at 2,500 feet. I think 2.25 2,500 feet is what this means. 2,500 feet. I don't know. Feel free to correct me. I'm an idiot. If I got that wrong. Anyway, so that's terminal weather. We also got SIGMETs here. So let's see. I need to make this fetch SIGMETs for non-US as well. Currently this is US only, but I'll make it fetch international SIGMETs as well. So we'll go ahead and fetch those. See if we got any. No, probably not. No SIGMETs found. Okay. Where are some SIGMETs in the US? Go to satellite display. SIGMETs. Okay, so there is a SIGMET between. Nothing in the continental US, not directly anyway. There might be something from, yeah, Tyndall Air Force. We go to Houston from Miami. We should intersect some of them. So go ahead and request something from Miami to Houston. Oh yeah, there's gonna be something there. Maybe. SIGMET info. There we go. 99 pages of them. Yeah, SIGMETs are not really all that readable. Yeah, that's the whole problem with SIGMETs is they tend to be extremely verbose. Really not all that useful for when you're talking about textual, because you can't really visualize this. Hey, leading edge. I'm an idiot, everyone in chat. Well, if you're an idiot. I'm a shoelace. Don't work. Yeah, not really. Anyway, let's get back to work. Terminal weather is kind of useful in that you can actually understand what it says. And then there's, of course, other stuff. So you got your ATIS stuff. And that's only data ATIS for participating airports. By the way, for some airports, the ATIS is combined. So you can select what sort of ATIS you want. Departure or arrival. And it actually even auto change this field. When you're in flight, it'll automatically swap to the arrival by default. So if I go ahead and request ATIS here, EDX data ATIS info whiskey special 300 blah 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 runway 3 shortened. Why do you have information whiskey? But some airports do actually differentiate this in reality. For example, DFW I know for sure does. So there are separate ATIS sets for DFW departure info versus arrival info. And then some of them actually just mash it together. So I know, for instance, that Denver, they like to smash everything together. Their ATIS is quite a bit larger. They're going to have like 4 pages, sometimes even 5 pages worth of ATIS. Provide you of information, Oscar. And currently, I've also got it working on, I think I have Pilot Edge installed, don't I? Yes, I do. Let's just make sure I'm not parked somewhere on a runway. I apparently am not. Good stuff. So we can connect to Pilot Edge and not, piss people off. Here we go. Connected to Pilot Edge. Good stuff. So now, when I go and fetch an ATIS, so you'll see right here. Currently, I have all of these are for these are real world ATIS informations, but if I go ATIS now, let's say San Fran, and this is now Pilot Edge ATIS. Will there be a visual? Well, it's directly in the text, so you can kind of figure that one out. Many of the same features for VATSIM. No, currently not Intel FX, because VATSIM and ATIS it's a complicated story. I might implement it, but VATSIM ATIS is it's a mess. Let's just put it like that. Currently, they make you fetch like a 1 megabyte giant blob of JSON to. You're gonna get all controller positions and all ATISs all over the world on VATSIM at the same time, rather than individual ones. And yeah, if you, I mean, I can. It's not a problem. As the text. Yes, PE has simulated data ATIS as well. So, by the way, if you try and fetch something that doesn't have data ATIS, where was I? Return AOC corporate ATIS. You can also get it from the ATS menu here. ATIS. Clearances, not sure if we're going to be able to do those. And TWIP, for sure I got to remove because that one's a weird thing that really doesn't exist in kind of any data fetchable thing. So we'll see about that. But ATIS. So let's say if you want to fetch something for an airport that doesn't have data ATIS, SBP for sure I know doesn't. You're going to get a wah. Data ATIS not available for that airport. It is TWIP. Yes, you did try, Pilsnerish. Thank you. So TWIP is a weird thing that I've never heard of before about a week ago. It's terminal weather information for pilots. Apparently a thing that only exists in business aviation. It isn't mentioned in, or I mean, I think the FAA actually does define that term, but it doesn't exist in the pilot's instrument pilot's handbook. It doesn't exist in in the FAR. It might be defined in FAR AIM, but yeah, I'm not entirely sure. But basically, it's a thing that barely even exists at all. Apparently, some ACARS data providers do have that kind of information, but honestly, I think it's really just a duplication of this terminal weather here. I don't know. It might be some different description, more like a wordy description, but I don't know. Just to be honest, decoding this, you kind of have to know what you're reading. I think terminal weather information for pilots TWIP is sort of a more worded out kind of style of info. Hey, Tail West, welcome. So yeah. Sigmets, terminal weather, winds aloft is what I'm working on currently. Send messages, we'll see which ones are actually going to make sense. These are implemented. Receive messages are implemented. These we'll see what makes sense. Technical is all fully implemented. ATN CPDLC, so that one's, and there's going to be also fans CPDLC. I'll implement those. I'll see if we can make it before release. Not sure. These are complicated because they depend a lot on network integration, because these are basically all about talking to controllers. Cool. Now, let's go back to coding. Enough diversions. Get rid of this. Back to here. Good stuff. Okay, so if this is 0, okay, so we want to clear U out, and TWX IKO is also going to be zeroed out. Good stuff. CDU scratch pad clear SPAD. Good. This is for delete case. This is for direct for station entry. Good stuff. Okay. Wind ALC request C. Okay, so terminal weather edit. So terminal weather edit. This is going to be winds aloft edit. When they're requested. Video color white. So this is not an IKO code here. And it's going to be the ident string. Good stuff. Ident. Good, good, good. And CMU winds aloft is requested. This auto position reporting use custom waypoints, and we'll ignore it. Use custom waypoint. Auto position reporting uses geographical position, so it doesn't matter where your it just reports where you are. It doesn't care whether you are near a database waypoint. 0 is not 0. It's not empty. And ident 0 is not empty. Good stuff. I'm gonna put in the request line, blah, blah, blah. Wind AL terminal weather request. Ident is not empty. Ident. Good stuff. But I guess it's different in the Boeing. I mean, it might put in whatever waypoint you're past. It might put in a name, but also going to put in your current position, so it really doesn't care. Some of these things I'm probably going to integrate on the Hoppy network for ACARS functionality, but we'll see. Because Hoppy is kind of all about ACARS. Good stuff. Ident 0, blah, 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 request. So this is not terminal weather request, wind aloft. Check that there are no mentions of it anymore. Good stuff. Request winds aloft. Good, good, good. And CMU subsystem terminal weather request. So it'll also look similar I'm just gonna copy this whole chunk here. Now, 666 data, unused data, and this is gonna be weather, CMU get subsys data, CMU subsys weather. Assert weather is not null. This returns to not the application menu, but the weather menu. And ident. Okay, and I'm gonna do here like this: wind aloft wall, and you're gonna be winds aloft edit, ident, wall ident, scratch pad transfer ident size of ident. Winds aloft is not requested. It's basically just transferring your input on the scratch pad over to some edit buffer. Then it checks if you've entered an empty identifier, then we'll clear out the entry there. Also clear out the position, clear the scratch pad, and we're done. Otherwise, if ident 0 is not an empty string, well, I guess that's probably kind of the obvious thing. So that's just the other case. Station location request for CMU current CDU. Yes. Ident. Station location target is gonna be winds aloft slot number 1 plus the number. Good stuff. Here's the trick. The reason why this seems kind of convoluted. Rather than just copying the string over to whatever the identifier for the station, we need also the position of the station. But the CMU has no navigational database in it, so it has to send out a request for a position resolution to the flight management computer. So it forms a station location request by taking the station identity, which is here. This is the text. This is characters, and converts it over into a packed 64-bit string. So that basically takes up to 8 characters of this string and smushes them into a 64-bit integer. Basically aligns the bytes in with together, in the byte order of the integer there, and then shoots it out to the FMC and says to itself, okay, when the response comes back, I want you to store it in the winds aloft slot number 1 plus number, whichever slot number that we're looking at here. Means I gotta actually go in here and I gotta design these. So station location, winds aloft 1 through 6. And 1, 2, 3, 4, 5, 6 winds aloft. And that way, when this guy gets the info, he's gonna look in here. Case station location winds aloft 1 through 6. Actually, there's a more efficient way of writing this out, by the way. This is a little trick in GCC. That's a compiler specific extension, but it's a fairly typical extension that most compilers support these days. Okay, so if we got a station location report, a valid position, then we'll pick up winds aloft T wall, winds aloft edit, wall -1. Yep. That'll be picking out the correct one. Wall ident. Yeah, whatever. Wall position is that thing, and then we clear out the scratch pad. to basically confirm that you've entered it correctly. Good stuff. So this will resolve the position. All the other crap is all in place now. Good stuff. So next thing, actually what I'm going to do here is I'm going to copy some of these terminal weather view. Going to be called CMU subsystem winds aloft view. CMU subsystem winds aloft view.h. So term wex is going to be wind al. Case sensitive replace. Winds wind aloft view. Yep. I don't think I have it set up for compile yet. Don't. So winds aloft request view, and finally there's also going to be waypoints, so being individual waypoints. Subsys wex, and we're also going to compile the C files here. Good stuff. Okay, that out of the way. Just for funsies, we're going to do a quick search and replace here, but I'm not going to have to customize these. So this grabs the wind info, winds aloft view, this grabs that. Yep, not airport, but waypoint open. Waypoint T. Good stuff. Kind of kills me that these are so similar, but mushing them together into two single files would probably make it less readable. Okay, so datalink view, winds aloft. Yes, I know that lone dash there looks horrible, but that's the way it is in reality. Actually, do I have some pictures here? Probably not. Not any ones that are handy. I do have something in here. That's fans functionality. But there. You can see that the dash really does exist in there. Yeah, all of them have it. License I didn't put in because who cares? And their technical menu has a few more items in there. The password menu here is for basically messing around with the thing in reality, in real time, discrete outputs, discrete inputs. That can and doesn't have to be in there. License is the thing I didn't bother with. Chime test is there. System config is there. Link status, peripherals, clock, all these are in there. Yeah, he does have photos. I just don't want to, you know, accidentally show stuff that I don't want to be showing. Didn't want to say. Okay, so winds aloft received. So when we visit this page, we'll clear the winds aloft received flag. Good stuff. Then next, we'll go winds aloft ident 0 is not empty. And the, let's see, lines. No, we'll do it like this for when is not 0. So that basically tells us that we've got data there. When this time index here is defined to something other than 0, then we know we've got data in there. That doesn't fit on the line. Always trust the manuals. Yeah. Wait, let me check. Maybe I'll be able to fetch some. Yeah, sure. I do have a few. Media, tank, XP info, doc, challenger 600, pix, datalink, and request segments, for example. That one I do have. Go location slant temp, for instance. So you can see a real thing does have them. In fact, it has a space there for request segments. You need to check if it puts them everywhere. It doesn't. Pretty sure it doesn't have them everywhere. No, only for that one. Well, that's annoying. Yeah, for instance, when I pull and receive message. Yeah, sure. Let's pick this one. This guy here. Oh yeah, you can see it's there on the real thing. I didn't make it up. Wish I had, because then I could delete them and make it look better. But whatever. Who doesn't love it when manuals don't match the real thing? Okay, so when's a loft received? We'll make here received. Yeah, we need a flag there. Also, when's a loft ident? And then for the next guy, so it's not an IKEA code we've got in there. Ident 0 is not empty. And when is not 0. In fact, I can actually unify these. Yeah, I'll make it like that. So print line, make it like that. Weather, screen, I, and on the left side, yep. Static bool, print line, oxt pointer, CDU screen, unsigned number, and bool side, or rather right. Wex screen number has to be less than num wins aloft. And if that is all true, in that case, we'll go ahead and smash these over there. There. Actually fits on a line. I'll call you NR instead of I. Number. And also number here. And on the right side. Number. Right side. Tell me about it. I have 2 EPR and 1 tables claiming to be the JT90. Yeah, I only agree on EPR, but not N1. Well, yeah, that's gotta be annoying. Cool. So now these are unified. So even though these actually didn't necessarily result in any fewer lines, what it does make is it makes the code a whole lot more readable here. So this is now obvious that it's printing both lines at the same time and using a common function to do it all. And in fact, I'm going to do the same treatment to the terminal weather here. Printing function. So go like this: static void print line const weather CDU screen unsigned number and bool right. Assert weather is not null. Screen is not null, and number is less than num terminal weather. Basically just checking for making sure we don't have any stupid overflows. Okay. Still doesn't fit, so whatever. But it will make this part a lot more readable. So I will be into number. Convert it over. Oh, we did lose a line here. In fact, we might be able to fit a line here. It's got to say right. And this also's got to say right. And with all that in place, we can go print line weather screen I false and I plus 3 true. There we go. So basically the print's left and the right side with an offset of plus 3 on the index there. So these are 6 entries total. The first 3 happen on the left side of the CDU, the others happen on the right side of CDU or the screen. In fact, I could probably make this like terminal WXT Twix. Twix is Twix like that. Twix. Cool. Twix received. And then finally Twix IK. Perfect. This makes it a lot more readable. Yeah, sometimes it does make sense to, even if it does cost you more lines in the overall output, as long as it makes the code more maintainable and readable and obvious what it's trying to do, that's always a help. CMU subsystem. Okay, so hang on. Did I actually IUN? I think I did. Yes, I did. Here you are. Good stuff. CMU subsystem, terminal weather airport. It's going to be called CMU subsystem, not terminal weather. Winds aloft waypoint. When we're viewing winds aloft at a given waypoint, in fact, through that, because that's going to be a completely different subsystem, because that one's going to print stuff out fairly differently. Prototype CMU subsystem, winds aloft waypoint. I'm going to write that one from scratch, so to speak. Well, obviously I'm going to use the template there. Waypoint.h. Winds aloft waypoint. Winds aloft waypoint. Yeah, I don't need any of, well, actually I do need this. So this will be winds aloft waypoint, and it's only going to contain the number of the entry that we're looking at. Winds aloft waypoint. So XXX underscore is going to be winds aloft waypoint. Replace all of those. We can, yeah, sure, we can leave the serialized functions there. Underscore is going to be like that. And finally, the winds aloft waypoint. I'll just call it waypoint for the whole words. There we go. This is the way I basically start out with a quick template, so I don't have to rewrite crap all over the damn place. Assert data is not null. Winds aloft waypoint. Call you waypoint constant. Also going to grab the weather structure here. So waypoint is our data. Waypoint is CMU get subsys data. CMU subsys weather assert WEX is not null. It's going to be false. DL space dash, and then it's going to be the name of the waypoint. And this is a request. We got view winds aloft and KMLB winds. Question is it going to be left or right aligned? It's going to be right aligned. Yes, I'm pretty sure. So like that, and winds. The 0 pages, yeah, because this is a fixed. So the number of subpages here sets if there should be a page number indicator, and if the subsystem has more subpages than just one. When I set this to 0, that makes the page indicator go away, and the next and previous buttons do nothing. So we don't have to worry about those. Okay, so number 1, actually, yeah. So waypoint and const winds aloft wall. So if actually we want to go ahead and assert 3U, that waypoint number is less than num wind aloft, so we don't actually accidentally try to access uninitialized data. Then we're going to grab a pointer to it, so winds aloft based on waypoint number. And so if wall ident is, for some reason it ended up being a 0, or somehow it got cleared out, or wall when is 0, so this basically means we've got an uninitialized entry there. We'll just swap back over to CMU set subsys, CMU subsystem, winds aloft view, and return. So basically this will quickly jump away from the page. Instead of us showing garbage data, we'll jump out of there. So this will show winds, blah, blah, blah. We don't want to do this. Instead, not even that. Instead, what we want to do on LSK header row of LSK1. So this is, it'll be LSK1 row. This is the header row of LSK1. So it's basically -1. On the left-hand side, using a, I'm pretty sure that's going to be green font. I don't have a picture of this, but I'm pretty sure it's going to be green font. And we're going to show 0.2D, 0.2D, 0.2DZ. And I got to convert that over to a struct TM. So struct TM. And that is a time T, so that's all good. So TM is pointer GM time of winds aloft when. So this function here, GM time, converts the time T field here, which is a number, that's a Unix time field. It converts it over to broken down time. And if we look, so this guy here, he takes a pointer to a time T and returns a pointer to a struct TM pointer. So I'm basically dereferencing that pointer and just directly storing that structure. And if you look in here, this is the broken down structure. It basically gives you a nicely broken down time. And it's in Unix time. That's why it's GM time. Or I'm sorry, it's UTC. So that's why it says GM time. So now all I got to do is extract the fields that I care about. So I care about TM day, so day of the month. Then we want to grab TM. Is it going to be 01 or just 1? No, it's going to be 01. TM hour, TM minute. Yeah. So that'll be our time of observation, or when that information was output. And then for int I is 0, int I is less than. Let's make this a symbolic constant so I don't have to. Num wind aloft alts 6. Num wind aloft altitudes. Num wind aloft alts. Num wind aloft alts I++. And so this is going to go into LSK +1 row plus I. 0. This is going to be in large white font. And it's just going to be, we're going to just fart out that piece of text there and just be done with it. So winds aloft, lines I, done. That's it. It's no more intelligent than that. Doesn't have to be. Is GM time threat safe? Yes, it is. Intel effects. You immediately think when you look at this, oh, holy crap, it's returning a pointer to something in there. But in the case of, fortunately, in the case of, buff environmental, oh, yeah, it's just an environment variable for the locale for GM time, and for specifically for local time, probably not for GM time. But in this case, I know that GM time actually returns a thread local variable. Well, it's empty unsafe because of the environment of the locale environment variable, but that is for this guy here for local time, not for GM time. Yep, it is thread safe. That's what the manual says. Really? Huh. Oh, in that case, I'll probably have to. Huh. Might be written by that, blah, 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 blah. Ah, okay. In that case, I'll have to write my own. Fuck that. Raise temp buff. Yeah. Yeah, raise temp buff. Yeah, variable, local variable. Damn you, libc. Yeah, do that. Whatever. I'll write my own then. Problem is GM time R is not portable. But that's not portable, my friend. That's the problem. It's an extension. Yeah, that's USB 2. And I have to run on Windows. If I didn't, of course I'd be using the recursive version, the reentrant version. So yeah, unfortunately, no. Let's see. Compile. 64. Right, so we don't care about anything here other than return back to the main subsystem. Don't care about any of that. Don't care about that. Don't care about that. This page has no entries in it or on it. There a version of GM time in ACFuels? No. There is time GM, which I had to basically copy of somewhere. There is an inverse function here, time GM, which does the opposite of GM time, because for some reason somebody really smart thought when they designed the C standard, GM time takes Unix time here and gives you broken down time in UTC, but there is no thing that takes broken down time in UTC and gives you this. That there's no inverse of GM time. Yeah. And you'd think that it would be something like here, local time or ASC time or make time, actually. Yeah. Make time. But unfortunately, that's in local time. So for whatever reason, somebody broken down time, they don't tell you, is that expressed as local time, not UTC. Yeah, no, I spent a fair amount of time on fucking around with this. So yeah, unfortunately, make time gives you, for whatever reason, it expects the input to be broken down time. I'm sorry, local time, not Unix time, not UTC. So you cannot do this. Basically, this kind of a sequence would be incorrect. I guess you could somehow compute some sort of an offset. I guess we'll see. I might have to do that for some other case. Anyway, for my own GM time or something. Yeah, it would have been nice, but unfortunately, no. So else return false. No, hang on. That's in the other file. Terminal weather view.c line 64. Yeah, that's nr. nr. Okay, here we go. Wind request with altitude request 56 string to pack. That needs a file from here, labels.h. That's what defines that little helper function. 59. Terminal weather. It's winds aloft, not terminal weather. Winds aloft position undefined. We'll set to null. 87. CMU winds aloft is requested. Declaration of function. Right, that thing needs to go in. Fetch this guy. 104. Ident is not. 0 is not empty, like that. 114. Serialize. Actually, winds aloft request does not need serialize functions. It doesn't serialize anything. Yeah, it doesn't. So go away, go away. Wind AL request. And this is also going to be wind AL request. Wind AL request. There we go. A lot fewer mistakes now. So now we're in winds aloft view. Line 42. All right, I got to define a function here. Waypoint.h. This guy needs a CMU winds aloft waypoint open, CMU t pointer, and a number. And so this is when you're transferring control between viewing all the reports and viewing only one of them. CMU is not null, and so we'll grab winds aloft waypoint t. Waypoint is CMU get subsys data. CMU subsys winds aloft waypoint. Actually, we'll also check for, so first assert that that is not null, and then assert that num winds aloft. You mustn't be asking for something that's not supposed to be there. Then we'll also grab const weather. We'll grab this guy as well. This guy's data set. And so if winds aloft number ident is not empty and we have data for it, for when is not 0, so only then is when we'll allow this. Basically lets you click on a button there in this list. Even if there's nothing there, we'll avoid switching to an empty data set. So waypoint number CMU set subsys CMU subsystem winds aloft waypoint. So that'll store which one you clicked on and then swap over to this subsystem and it'll hopefully show the right one. 67. Winds aloft view. Hang on. Wrong one. 67. Print line. Okay, that shouldn't be a bool. Okay, winds aloft waypoint. Line 72, winds aloft wall. Okay. All right. You need this guy, wax impl 90. CD page, right. It needs the wall ident. Cool, getting closer, getting close. Wex.c 636. Means station location wall 1. Okay. Oh. Typo. 912. CMU wind AL is received. Okay, make it compile a bit faster. Stuff. Now, one more thing. The CMU here needs to understand when winds are received. It needs to, so the CMU master basically handles the little button here. The R6 button always shows the latest piece of information that was received, and when you click it, it takes you to the appropriate page. This guy here needs to understand when winds aloft are received. So this guy needs to actually fan this out. Wind AL is received. It's going to say winds. And there's a default button interaction function here. And when winds aloft are received, wind AL view takes you there. Go close. Oh, one more thing. I gotta take a 5-minute break, and I'll be back to finish up this functionality, and then we can go ahead and test it. Almost there, folks. Almost there. Stay tuned. Just 5 minutes. Okay, back to business here. Sec. Rock and roll. There's a piece I missed here that I forgot, which is at the end of the Winds Aloft functionality. There we go. So when we complete the request, we want to first finalize Winds Aloft request CMUX. I'm going to come over here, and so basically right now there's a couple of data structures that it's looking at while working. Smoke them if you got them. Yes, sir. So Winds Aloft edit, you'll see that these are all the same structure. So this is basically what you see here. Here, this is the editing portion where you're selecting what you want to see. Then this is basically the output portion that's displaying what it already has fetched. But there's another one down here, another set of them in progress. And so that these are the ones that are currently in progress, in the state of being fetched. And so I got to take these and incorporate them into this list. And the way it does it in reality is even though you can basically put in identifiers anywhere you want on this page, so you can put one here, put one there, it then when it's finished fetching them, it'll smush them all on the left here. And when you got new ones, it'll basically push the ones that already fetched the old ones back, and it'll put them on the top of the list. Or otherwise, it'll if they are already pre-existing. So if, let's say you KADS and you fetch it again, it'll replace it in place instead of putting in a new one. So basically, I got to put in that where it takes it from the progress list here and incorporates it into the final output list. I already got that for, and it does the same thing for terminal weather here. So it's already a solved problem. I just got to copy over the type solution here. Where are you? So first of all, clear the air, as they say. So make sure that the input variables are defined and good. We don't want to be ingesting garbage and working with null pointers. Or more accurately, if we get anywhere within smelling distance of any kind of a bug, which would be the case if these were null, we get anywhere within smelling distance, see, finalize terminal requests, terminal weather, so finalize, I'm going to call these finalize winds aloft. When we get anywhere within smelling range of a bug, we immediately want to basically kill the machine. We immediately want to stop execution, and we want to, you know, fix the bug, get as much debug as we can, and dump out of there. Okay, so we can go ahead and clear that away. So for number, we're going to go back to front actually on the list here. So we're going to, because we push them on the top here at the front, we're going to go back to front from the original request inputs. So as long as these are found, blah, 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 blah. Okay. So winds aloft in progress, ident 0 is not empty, or rather it is empty, or winds aloft in progress when is 0. So we basically didn't get correct data for this, or that field is empty, and we'll just carry on. One more thing I forgot. Sorta. Winds aloft. So winds aloft request .c, and whenever we edit that in there, while when it is going to be set to 0, so that basically clears it out. Good stuff. That makes sure that we've got nothing there. So number of winds aloft, we're going to winds aloft, winds al ident equal to, oh, we'll go ahead and compare. So in the case, it worked for airports because ICAO identifiers are unique, or almost guaranteed to be unique. But for winds aloft, you can request for any waypoint, and these there might be ambiguities. For example, for whatever reason you requested winds aloft for 2 different waypoints with the same name, we want to disambiguate them, not based on identity or name, but based on position. So we'll go DC distance, great circle distance from here to, let's see. Position, not terminal weather, but winds aloft is less than, let's say, 1 mile. That basically means that we're looking at the same thing. But I also want to make sure we don't accidentally try and ingest garbage in here. So if not is null geopause, and I don't want to feed this function any garbage. So this is an undefined position where you want to skip it. So winds AL, wind AL, and wind AL in progress. Received true, found, true, break. And if not found, then we'll just move the whole list down by 1. Num winds aloft -1, size of the winds aloft T structure, and then we'll stick our input here at the head of the list. Good stuff. And finally, not terminal weather received, but winds aloft received. Then it says cancel. Really what it means is stop the request. We were done with the request. So basically they'll stop it, and then we'll notify the CMU that we've got a new message that'll make it play the chime sound. Rock and roll. Let's go ahead and test this sucker. Hopefully it's not going to blow up on us spectacularly, though it might. It probably is not going to work well on the first try. Never does. Cool. Hop in the simulator. hook up ground power again because that got disconnected. It's still sitting on the datalink pages. That's why it's blank there. As soon as it gets ground power, they'll come back in. And the FMS is fairly unhappy with lots of messages flying past us, but who cares? We're going to speed up time here so we get datacom link faster. We'll go weather, winds aloft. Now, first I got to, I don't even have to time accelerate because I forgot to put in some key interaction. So this is going to go on L3 is going to go to the winds aloft request. Then over here, you're going to go on R3. You're going to go to the winds aloft view page. See, this is the sort of stuff what I said. It's never going to go work on the first. Can you request winds aloft at vectors? Yeah, probably not. SLU flyer 06. If I'm reading right. Small font. Welcome. Change these windows between each other so you guys are closer to me so I don't have to look over quite that far. Good stuff. Weather. Winds aloft request. Request winds aloft. Good. View. Should be empty. Good. Let's test some keyboard interactivity here. We can request at an airport. Good. Let's see. I know this is a VOR. And Wolfair737, thanks for the follow. And let's see if disambiguation works. Yeah, okay. There's a lot of pages to pick from. What if I return back? Okay, nothing happened. Alpha November. I pick it. Good. So this is kind of a... Anson Crusher can use my Discord name. Ah, right. Blue Flyer. Just put like Instant Crusher 1 or something. Alpha November. So here's a trick. When I'm doing this kind of a disambiguation lookup, this second page is actually shown by the FMC. It's the FMC itself that is showing this. But when I go back, it jumps back to the CMU subsystem. So the CDU had to disconnect from the CMU, connect to the FMC. Basically, it was really done by the FMC. It says requesting attention, please talk to me. It quickly then popped up the page for the waypoint selector. You see momentarily it showed the status page there. Then when it goes back, we again say, okay, now go CDU, go talk again to the CMU, and we'll on another channel, we'll send the position information for that, for that whatever lookup we did. Because obviously you can have multiple of these guys here. So it can be NDB there, and can be an NDB, or not even an NDB. There are a localizer named A, and of course somebody else, whatever, a DME. Or what about A? You think that's a valid that's a valid entry name? Yes, it is. In fact, you'd be surprised at how many things are called A. 16 pages worth of them, so 2 per page. That's around 30 of them. Is it 32 or 32? Not 31. So there's 32 things in the navigational database just called A. Same thing for B. 15 pages of them, so there's 30 of them. Yes, single letter identifiers are allowed. I think X is not allowed. Or actually, I stand corrected. Apparently it is. And if I enter something completely stupid, A, B, C, D, E, it'll say not in database. And crucially, it will not erase my scratch pad here. Basically, let me, correct whatever mistake I made. And if it is an unambiguous entry, so let's say an airport identifier, then it won't even prompt me. This is a VOR and it is not ambiguous, so that will not even prompt me because it knows. Maybe Biggin Hill, BNN, I know. I don't know. No, it's Bovington. What's Biggin Hill? It's BIG or something like that. Apparently there's a lot of them. They're named that. Give me an unambiguous one. Hang on. UK. Midhurst. No, Midhurst I think is ambiguous, but Goodwood isn't. EWC. Yeah. That one is unambiguous, but Midhurst is ambiguous. So in that case, it gives me two options. And this is sorted based on distance from the aircraft currently. So right now, this is in Mexico, Merida, BORDME, and that one's closer than obviously the one in the UK. So I could select that one instead. Ah, I forgot to put in the button here. Didn't I? Okay. So let's go ahead and pause here. Point the thing into the sky. It's not consuming a lot of GPU for me. Let's see. Winds aloft request.c. Yes, I forgot to put in a button there. I think I've got a thing I can reuse. Yes, check can send. That needs to be actually a similar function. It's going to be named the same, but it's not going to work the same. Check can send num winds aloft. Ident 0 is not that. It's not empty. No, hang on. All right, you just need at least one of them that has a non-empty name. Good. And it's going to be looking at the winds aloft. Edit data set. Good. And so R5, yes. And these need to do two different functions. When you're on the R5 key, and it is currently requesting winds aloft, then we'll cancel the request. And it'll request cancel. Otherwise, if we can send data, then start it. Winds AL send request. And return back to the weather subsystem. So basically it'll jump out of this list here and back into this main list. Good stuff. Next thing. And here I forgot to put in the send key. So if winds aloft is currently requested, then we'll make it delete. Yeah, right, no, good. If winds aloft is currently requested, then there's going to be a cancel key there. Otherwise, it's going to be a send key, and it'll have a star after it if we can actually perform the send. That's what signifies to you that it can initiate the send. Basically, it just checks to make sure you have at least one identifier entered in here. Good stuff. Point it in the sky. We don't need to look at the airplane and have it drag down the frame rate. Well, it doesn't really drag down the frame rate. It's still running at 60 FPS even inside of it, but it just consumes a lot more power and makes my machine warmer. Gotta realign the IRS here because I've been sort of messing about with the same thing. Cool. AOC corporate weather winds aloft request. Oh, right. Yeah, I forgot to put in a piece. So the reason why it's still showing this list of entries is because I actually need to make them clear out when the CMU goes through a power cycle. So when it power cycles, these entries are lost. Where's the reset function? Damn it. Reset function here. Okay, terminal weather edit. So we'll clear out the output and the input, your editing version. Terminal or winds aloft, and also winds aloft received. And we'll also get a cancel the request. And MIT's plays, thanks for the follow. Winds AL, cancel request. Yeah, so this is for when the thing is powered down. Segments, cancel request. Terminal weather, cancel request. Winds aloft, cancel request. Anyway, so for now, we'll just go ahead and send it, see what happens. In fact, I don't know, we're not going to send it right now. We can actually, I'm going to enable this debug flag here. And you'll see in real time how it simulates the data transfer. For that, I got to show you my terminal. Good. AOC corporate is on. Yeah. Up in the sky. Weather, winds aloft. So now it cleared them out after the power cycle. Good. Nothing in there. Good. And we'll bring up this here. Where are you? Corporate data link or data link display. And now I'm going to show it like that. And time accelerates so that we can get a VHF lock faster. It takes about 2 minutes for it to scan through all the frequency bands. And afterwards, it'll link up to whatever it has as the best station beacons. I might have to make the timeout for removing a station beacon longer, because right now it's 2 minutes. It should probably be more like 2.5 minutes due to scanning time constraints. There we go, locked on. So we are now locked on SITA on the city setup provider at MCO. By the way, these are, yes, you might have guessed, these are not ICAO identifiers. The stations are identified by their IATA identifiers. For whatever reason, they use that. Since ACARS really is a thing that, you know, isn't for, you know, little private airplanes and stuff. So first off we'll try fetching at the airport here. And over here, we'll jump right like that. And you can watch the thing do the request in real time. Well, something is there. And I forgot to put in a line here, which should say received. If I click on you, it says CAMCO received. Good. And something that looks kind of reasonable. 04, yeah, that's 4th of July, obviously, and 1200 Zulu, so good stuff. 18, 24, 30, 34, 39. Funny story is I never actually ran this code before, obviously right now, since we just wrote it. Good stuff, though, that we didn't, obviously, not in a trivial way screw it up. Let's see if, and you can see the exact URL that it fetched from. So if you wanted to, you could probably just go ahead and you could wget that and confirm that the data returned is correct. And I want to grab you in less and don't go quiet. Good stuff. So it's returning it's returning a GFS analysis for a grid point that is 12 miles from our request. 300 degrees away from it. This is GFS only operates in half-degree world increments, so this is obviously not going to be exact data at that point. But you know, 12 miles at high altitudes, it's close enough. Half-degree increments on a grid point that is every about 55 kilometers. You're going to have a data point, and in between them, you know, whatever, it'll grab the closest one. The worst case, you're gonna be about maybe 25 kilometers away from your request. In this case, we're probably about near the outer edge of that grid point. So 12 miles, probably, you know, 16 miles, 17 miles will be the worst, which at the flight speeds of these aircraft is about 3 minutes worth of flight time. And at 3 minutes, the wind and the temperature ain't gonna change all that much. Good stuff. So we want to check for our correspondence and data here. So 18,000 in feet is going to be 5,500 meters. So it's going to be about in between these two guys. And so the wind is supposed to be about out of the west, 25 knots. And it says that's stupid stuff. Hang on. I did compute that correctly. So this is probably calculating something wrong. Oh no, sorry. I'm looking at temperature. 24 knots. Idiot. So minus 7 degrees Celsius. And so our temperature. Hang on. Yeah, minus 7 degrees Celsius. So this is in tenths of a degree Celsius. So it's not minus 34, it's minus 3.4. Minus 7.3. And so it's probably more like minus 6.6, but it rounded up because it just is in whole degree increments. 24,000 would be, and by the way, this is assuming barometric standard gradient. 7,300, so it's going to be just under this one. It'll be 24523, 24523, good. And minus 16.8. Yeah, minus 17, close enough. It rounded up, or rounded down actually. Makes sense so far. Let's have a look at the last one in the list. Stand by. 13.7. 13.7. Gonna be closer to this guy. 246 at 30. 246 at 30. Good. This doesn't really change very much. And minus 68.7. Minus 69. Yeah. Pretty close. So this is our current location. By the way, that would be real world weather, obviously. But am I actually close enough to be using automatic real world weather? No. So currently we are just letting X-Plane use whatever weather it wants. But what I can do is I can go and yeah, sure, let's enable real world weather. Close enough. And so now you'll see that the temperature simulation here is going to start picking this and coming and bringing it over closer to, well, currently it's going to place the temperature at wherever X-Plane thinks it is. It should be, because we're not using the gradient data here when we're very close to the ground. We blend them. So within 5,000 feet of the ground, we start more closely coming over to X-Plane's weather data rather than using this temperature gradient here as GFS data. The reason being that GFS down low to the ground is fairly inaccurate. It's more for the upper altitude or mid to high altitude stuff. So close down by the ground, you should normally be using METAR and sort of local reports, and that's exactly the way that this thing works. So the closer you get down from below 5,000 feet, the closer your temperature is we're gonna let it approximate wherever X-Plane thinks it should be. So currently it should be about 29 degrees C here. Thereabouts, yeah, 25, 29 something. So that's what we set for the engine simulation. By the way, so these inputs do not factor, unfortunately, into the aerodynamics, because I can't, sort of can, but not trivially affect X-Plane's temperature model. But it does factor into things like, for example, the temperature simulation for stuff that I do. So engine thermodynamics, air conditioning thermodynamics, that kind of stuff. It's a forecast, right? This is a combination of a forecast and a model. So the soundings are based on vertical soundings and satellite data, but it is about a 3 to 6 hour forecast, I guess, window. Really above 5,000 feet, or above about the immediate friction layer down below, close to the ground, your winds do not really change all that much on a short-term basis. So below 3 to 6 hours, it doesn't really change, and temperatures also. It might seem like that's not the case. Yeah. It might seem like that's not the case, but that's really what it is. So above about 5,000 feet, when you get out of what they call the friction and mechanical layers of terrain interacting basically with the air, when you get high enough, both your wind, which is basically caused by a pressure gradient, and your temperature, which is caused by the adiabatic gradient, those are primarily dominated by large-scale phenomena, basically weather fronts and high and low pressure zones. And those, if you've seen if you're obviously if you're a real-world pilot, you've been tortured by with this in training, but in reality, those are almost continental-sized phenomena. A pressure zone can easily be 1,000 kilometers across or more. So for that thing to move reasonably far, it takes a few hours, and that's basically at that point what drives your wind direction. It basically goes from high pressure to low pressure. That's called a geostrophic wind. And high altitude winds are caused by the Coriolis effect, and that again changes very, very slowly. Several hours for the thing to actually do anything. Same thing for temperature. Temperature changes do happen due to convection, but again, these are low level effects. And above that, you're going to be looking primarily at the adiabatic pressure gradient, which is based primarily on things like moisture in the air. And even though you might think that things like clouds and weather fronts can move fast, it takes several hours for a weather front to move from to really not just weather front, but really the moisture gradient to change significantly at a spot where clouds can start to develop easily. 3 or 4 hours for the thing to significantly change. It can be little changes, but large scale changes take a long time to develop. And above 5,000 feet or above the immediate low levels, that's what basically drives the majority of weather. It's the slow moving mass of the atmosphere. Cool. Go back to here. We'll try some more crap. Let's go and test if we still got sound, or if we get the chime. The weather request, winds aloft. Let's request something different. Some different airport or different location. So KMCO, what's a nearby? I don't know. You can go ahead and request something in the ocean, or I don't know, a grid point. What are you going to be called? Yeah, 3076. So you can do these kinds of requests as well. This is a database waypoint, so that's why it understands that. This will be 30 north, 76 west. Or it would be 30 north, 76 east, if I understand it right. Cool. So let's go 3076N. Cool. So we got 2 of them. Good stuff. It's returning the wrong major page there. So let's go back to here. Winds aloft. Waypoint. And you got to return to the right page there, mister. Not to the application menu, but you got to return to winds aloft view. Yeah, okay. And also in wex.c, you gotta show, there's a draw function here. You have pyraps. Man, that's a lot of crap here. No. Firmwex? No. Wex.t. There we go. And I gotta put in the status display for this crap. And so for winds aloft, you're going to be LSK 3. Good. Sweet. Reload. I mean, obviously, Pilsners, they're not going to have, they're not going to be launching weather balloons every 3 hours for the entire planet in a half-degree increment. That's just not practical. So no, they don't. Yeah, that'll be tens of thousands of weather balloons every hour. So no, they don't. That is, they do samplings at a certain set of points, obviously for the vertical column. Then you have satellite data for modeling, weather fronts, and the rest of it you do by supercomputer. That's what your supercomputers are for. Real-time wind or weather modeling. Close as you can get it anyway. Would be pretty awesome though. Well, it would certainly look like a permanent party everywhere, all over the planet. The amount of balloons. Probably quite a lot of garbage out of that as well. We'll also make aviation sporty. Yeah, dodging weather balloons all the time. Weather winds aloft. Let's pick another one. Let's pick, I don't know, we could pick something along our flight plan. So let's go to here. Sure, why not? Jocks, go to datalink. Weather, winds aloft. Boom. And by the way, you'll notice now it says request, but we've got no comm there. So right now it's just sitting there and waiting for communications to come back, and it'll sit there for up to a half hour. So yeah, you can queue up requests on this thing quite a while ahead of before you get there, or before you get datalink comm. Now I don't have, I'll implement the SDU next probably. So the satellite datalink unit, which runs also at 2.4 kilobits, give or take, but it gives you essentially global coverage for datalink where you don't have local. Okay, says received, good stuff. Winds, jocks, return. We return here, and that should have cleared that flag coming up to this page. So I gotta fix that. So WAL and received is false. What? Oh, right, we're using a const here. So go away const, don't make this const. And we also gotta remove the const there. Good stuff. So viewing the window here should clear that RCPD flag. Another reload, another reload. Yeah, it doesn't really like it when you power cycle with just GPU power on. Good stuff. So AOC corporate, you can queue up quite a lot of requests. So say for instance, I can queue up a terminal weather request here in Orlando. Then I can queue up some weather over, what was it, jocks or something like that. Sure, queue that up. I can queue up, sure, that as well. And now you'll see it fans out, so to speak, so I can see if I've got some crap there ready to go. I can queue up some there. It doesn't propagate out to here, but you'd be able to see that you've got a whole truckload of stuff queued up. In fact, I could queue up a flight plan data link update. So let's see. Flight plan wind updates, send that as well. And now this is going to take a while. We can watch the poor sucker suffer as we give him a truckload of wind data or data to fetch. But a data link, and now we'll see him when it finally locks onto a station. It'll go into VHF in progress for quite a while, and we'll get a lot of messages. Still got to implement you. We could also queue up a flight plan downlink. Why not? Flight plan recall. Tail number is 650. Go. All right, that needs to go to a different menu. There we go. Locked on. I'm going to show you here how the thing fetches data. We got winds. Didn't have too many of them. Go back. It clears the flag. Good stuff. We've received SIGMETs. Also got ATIS. Well, didn't get ATIS because there's nothing available there. So let's go ahead and grab the MCO. We've already got the flight plan downlink ready. Or data link flight plan, sorry. And also, when you get a message, it'll pop up a thing here. We'll get green data link. Got the ATIS. Got weather. We have nothing else in weather left. Okay, so now at this point, it's just doing the flight plan wind update. And to clear this flag, by the way, you got to visit the secondary flight plan here. That clears it out. And this thing needs to go. Let's see. FMC subsystem. FPLN recall. Still chugging. There we go. Data link winds updated. Cancel. So yeah, it takes takes a lot of time to download when you've got a truckload of stuff queued up. Anyway, so this guy here, he needs to not go to the app menu, app menu. No, hang on. FPLN recall, route menu, and CDU page CMU. Yeah. Oh, it's gonna be up here. CDU pages, CDU page CMU. And when you open up, or not. This is, by the way, not something I'm doing. This is explain itself. Fetching weather, apparently. Let's see. Where do we select where we go? Let me think. Flight plan, route menu, flight plan recall, data link. Okay, no, I know. It just goes to the last window that I had displayed there. Good, so there's nothing to fix there. Yeah, it goes to the last page that was displayed in data link. Neat. Let's make a bigger flight plan. How about that? Let's do a long boy. New flight. Here's your pilot ID, by the way. That's what you've got to copy in there. Let's go call you ABC123. Who cares? I like to do on Gatwick to, I don't know, Teterboro? PHL maybe? Philadelphia? Something that's reasonably far. Yeah, sure. Atlanta's too far to reach. With a Challenger anyway. Cathal. Oh, no, it isn't. I stand corrected. Maybe it might be doable. It really depends on the winds, though. If the winds cooperate, we can. It'd be marginal. Let's try that. Atlanta. Sure, whatever. 10-hour flight time. Yeah. That might not be doable. So the Challenger EDFE to Teterboro. EDFE. Not to Atlanta, but Teterboro. Teb. 9 hours 10. That might be doable. EDFE to Teb. Yeah, that might be doable, depending on what sort of flight plan Simbri spits out for us. Okay, there's some crap. Uses invalid endpoints. We'd have to pick a different ADDF. Let's try if it gives us a better flight plan with ADDF. I just don't want to be, spending too much time thinking about a good flight plan or whatever. And I don't need NOTAMs, FIR NOTAMs, runway analysis, ETOPS planning, detailed nav log, whatever. I just really need the what did you not like? Number of fields required. Oh, right, aircraft. What's the Challenger? Sure, whatever. Generate, yeah, sure. I don't give a shit. Okie doke. So, sim brief is done. Jump over into the airplane. And we can place ourselves over there somewhere. I don't know. Or is there even a business ramp at Frankfurt? Probably not. Who cares? Hopefully my sim's not going to implode here. And over in Frankfurt, we're going to have, we're going to have VDL mode 2 there. It's going to run a lot faster. Frankfurt has a SITA, I think, yeah, it does have a SITA VDL mode 2 radio transponder or base station there. So hook up AC gen. Yeah, normally you wouldn't do it quite like that. You'd go here and then you'd show your AC power. And before you hook up a generator, obviously you'd want to make sure it provides good power instead of frying the aircraft. Come on. I did select you, didn't I? Ah, there you are. So 115 volts, 400 hertz. Boom, rock and roll. So, and so here we are in Frankfurt. And we can also show the, let's see, nearest airport, so you can see I'm not making it up. Cool stuff. What Challenger profile did you use? So I used the Challenger 300 and then I did some modifications to the max gross weight and stuff. Index, route menu. You could, you could select your own. You could, there's a disk route list support. Yes, this does work. Reading media, reading. And even this works. Let me show you. Let's see. Do a flight plan recall. We could go, hang on. Got a route menu. What's our current flight plan? MCO to Key West. So go to route menu. Pilot route list. We'll call you MCO to Key West. And we'll do an active store. So this stores the flight plan. Now what's this? This is picked out from your, this is essentially simulating as if you had a USB stick stuck in a little thing called the database unit. What we're doing there, we're actually looking at output FMS plans here. So it's showing this list of flight plans in here in X-Plane. But you'll notice that it doesn't have, so the pilot route list is stored directly in the FMCs, whereas the disk route list is what you have in a USB drive. So basically the external drive here, or external folder. to get your internal pilot routes over into the disk routes in case you do want that. We can do that. You can do that by going to index, dbops, insert load media, and you hit write routes. And you'll see suddenly we have KMCO keywest.fms there. So if you have a different flight planning tool other than SimBrief, you don't have to worry about having to punch in the flight plan manually. All it's got to do is it's got to give you an export of a .fms flight plan. So as long as it can produce an explain.fms file, then we are able to load it in. And we do that. You'll do that by going to route menu, disk route list, read disk, and it should show up right there. In this case here. Or if you want to do it the intelligent data link way, let's see, is data link connected yet? It is. And in fact, it should probably be running in, ATN.com. So it's running in SITA EU. It's running in VDL mode 2. You're going to see some blazing fast downlink speeds here. If I bring it up here, you'll see that the channel bandwidth we've got is 28 kilobits. Amazing, isn't it? So we hop over here, flight plan recall, punch in my tail number. By the way, the reason why some of the stations here are blue is because they are VDL mode 2 stations. So the black ones are VDL mode A, or analog ACARS. That's 2.4 kilobits. Blue ones are VDL mode 2. That's 31.5 kilobits digital data link. Anyway, come back over here. Go ahead and send it. There we go. Downlink flight plan rejected. Why? What did you not like there? Data link flight plan, I mean. Good question. Anyway, let's have a look why it rejected that flight plan. There's probably a reason. Request pending. Data link flight plan rejected. Huh. Ennis Adonis, welcome. Welcome, welcome. Probably failing a route parse, so have a look at the thing, what it's failing to do. FMC subsystem flight plan manager.c DLFPLN rejected. So this is the guy who asserts this message. Uplink fail or parsing fail. Okay, so break, and we'll break in FMC subsystem FPL manager.c line 2234. Send it. So here we are. Delete the breakpoint. CMU flight plan uplink fail is not set, so it's probably a parsing problem. Actually, hang on. Here we go. I didn't even need to stop in the debugger. Data link flight plan rejected. And so here's our reason. RKN LTO6. There's a piece of the flight plan that it didn't like. That's matching my modem from 1996. Yeah. Amazing, isn't it? So, question, why is that is a problem apparently? Well, let's have a look in the navigational database. So go to explain I'll go to custom data, Earth fix. So we're looking for, actually no, we are looking at Earth Airway, RKN. Okay. And we're looking actually for a single word. So RKN, RKN. L206 Echo Hotel. Let's have a look at the flight plan actually. At the flight plan itself. What I can do is I can stop here, break FMC subsystem. Actually, just break in this FMC again, and the uplink request again. Pause, and I want to look at the exact string and what it returns. CMU flight plan uplink FMS bytes. Okay. Maroon direct. So this is 11. Let's just step through the thing. How about that? So step, next. It's an FPL SCR. Sorry for the brief interruption there. FPL SER 463. Okay, so now it's starting to look. So N lines, we've got 54 lines of flight plan here. Lines 0. It's nothing. 4, 5. Let's look like 10. Okay, 9. There should be. Which line did it not like? Does it say? And 3 arcane. So this is not a line number. That is a type of entry. Okay, never mind. We'll step through the thing. Display lines I. Next. ADEP. Number en route is 48 waypoints. EDDF. Maroon direct. RPEG. Badgo Abilu. Just stripping spaces right here. I could just go ahead and see. Break FPL SCR 478 if lines I, and it was 0, 1, 2 is R, and lines I 3 is K. Otherwise, also break at FPL SCR 507. Huh? Okay. Okay, undisplay everything. Okay, display line display lines line I. Airport departure EDDF. And break at FPL SCR 508. Delete. And what other breakpoints do I have? Delete 78 and 77. Continue. What, we never got there? The hell? Oh, I skipped the en route portion. That's first up in here, isn't it? Num en route. Yeah, crap. Yeah. First ENR line. I should have stopped there. So break in FPL SCR 624. Delete 79. Yes. I know. We didn't get it. Re-download. Cool. So got the breakpoint still set. So continue. RK, there you are. So it's line I-15. Add line number to the error message. It's line number 15. We were at, so this is L206 to Relby. Have a look. You can just type it in Relby. Probably failed to construct the airway segment there. Give me Relby. Then there should be an L602 or an L602 to RKN. There's a teeny tiny airway segment there. This piece, this piece. So why didn't you like it? Step in. Next. 389. Parse the en route line. Next. So. Type is 3. Yeah, so that tells me what the type of waypoint that is supposed to be. So line 3 or type 3 should be VOR. Is based on right here. So type VOR, waypoint type VOR. Then we are here. I think there's a way to make, or is it like that? I forgot. Whatever. 439, check append leg. So what's our VIA currently? L602. Good. And pumps to L602. Check append leg. 361. Check via match. Previous via, next via. These should match. So what's your problem there? Do we have a waypoint? Yes, we do. I found it. Good. This should not cause a new waypoint to be emitted. Good. 439. Also, yay bugs. Yeah. Oh, a question is it really a bug? Probably is. I didn't want to do pen leg. So 442. Now we're here. Waypoint DB. Look up any comps 1. RKN. Type is 3. Yeah. Geopause to AF comps 4 and 5. Let's have a look. So in EarthNav, we should then have an RKN en route. Chersky, no. Reckon, that's the one. No. Yeah, no. Yes, that's the one we're looking for. Should be a 5213-676. That's close enough. 52113197. And I'm gonna bet it didn't find it. It's not gonna find it. Okay, so let's look in about here into here. Waypoint DB lookup any 2. So waypoint DB lookup any 2. Okay. Max distance. What's max distance? Max distance. 50 kilometers. So if we're anywhere close to it, we should be able to find it. Okay, so break in ARAC C 1079. Name RKN, IKO, nothing, CC, nothing. Type, waypoint type VOR. Ref point is there. Right. RKN 52113. Yeah. Okay, so that should still be okay. Hash table multi-values. So it found a multi-value entry. Waypoint. Name. CCEH. Yeah, okay, good, good. IKO is nothing. Waypoint type. What are you? Oh. All right. Yeah. That's the trick here. I need to think about this. Stand by. Let me just quickly turn on some lights here. Getting a bit dark. Alrighty. So let's put our little thinking hats here. Yeah, so for flight plans, there's a little bit of a special case here because they don't note it as the proper type. Rather, they consider the type to be VHF anything when it says 3 there. Right, how do we deal with that elegantly? Oh, I guess this guy's got to have a special case here. Yeah, it's gonna have to have a special case here. So for, have a look, what other waypoint types do we have here? So VOR, DME only, maybe. We can just go ahead and check for that guy. This is a co-located DME, this is a standalone DME. Yeah, that guy just needs a special case there. Do a secondary lookup. So if 2dB is null and type is waypoint type VOR, then do a second lookup trying to look for a standalone DME. So like that, and waypoint type DME only. We need to, a couple of, no more on extreme. We need to special case waypoint type VOR because 3 in FMS flight plans means any VHF nav aid. Any VHF nav aid. Yep, that'll fix that. Yes, RKN is only a DME, even though it shows, even though the symbol here in Sky Vector says that's a VOR DME. That's an incorrect symbol. In reality, it's a DME only at this point. They retired apparently the VOR portion. If there ever was one, no longer is one. Cool. So send the flight plan request again. We gotta wait for datalink to link. Do this little link thing. I'm gonna time accelerate so it scans through frequencies a bit faster. Fortunately, I'm not connected to Pilot Edge anymore. Happening a lot these days. Yeah, there was another one in Switzerland recently that I found by literally debugging and trying to figure out why the hell my thing didn't work. Turns out it was because it no longer existed the way in the database that I thought it did. Come on, you're taking forever. Here we are. See? Datalink flight plan, load it. Lovely stuff. Jump in here. And there we go. EDDF to Teterboro, activate. And that's a long flight plan. So go to secondary flight plan, activate. Like that. Now, normally what you'd go before fetching winds, by the way. You shouldn't fetch winds right away. You can, but you should first fill in your cruise altitude because that lets the FMS construct a vertical profile for your path. and also put in a departure and whatever. Let's say we'll depart runway 18, and is there something that takes us to Maroon? Yes, there is. Or something like that, I guess. Execute. Let's check for continuity. What am I? Can't talk. So there's 11 pages of waypoints. So that's 55 waypoints, give or take. Something 54 waypoints in the thing. That's over VDL mode 2. That's going to be a quickie. Going to be a quick one. So go to perf init. Go, let's say, flight level 360 maybe just about would be achievable on a full fuel load. Now first it's going to complain, probably. Oh, did I enter enough fuel here? Yeah, if we loaded in 20,000 pounds of fuel, but more realistic would be something like 19.6, and if I do that, you'll see it starts complain and check fuel at destination. But currently it expects us to fly at a fairly high speed, so let's drop the speed. We might be able to make the fuel work out. There we go. So we gotta go Mach 0.77, maybe Mach 0.78 will be doable with some reserve, but more likely Mach 0.77. You can just type in 0.77. Enter. And that'll leave us 2650. But we haven't factored in wind yet. So we might have to go even slower. We'll see. And we'll go Mach 0.78 in the 77 in descent as well. And 280 knots or 270 knots or something like that. Enter. Good stuff. So currently estimate is 8 hours en route, 2670, but we haven't fetched winds yet. So go to route menu, flight plan wind update, start the wind update. Yeah, if we look over like this, you'll be able to see the thing doing the wind update there. And this is running over VDL mode 2, so it's a lot faster than if we're running over VDL mode A. We might have to go even slower to make up for the difference in flight time, because right now it says 8 hours 6 minutes. Says what the hell? Maybe there's a bug in my performance calculator. Flight plan winds updated. Good stuff. But what is the average wind gonna be? Actually, not bad. These are mostly southerly winds. A little bit southwest, yeah, from the southwest. But winds are fairly benign. That comporting with reality, or did I fetch bad wind data? I don't know. That is, we managed to avoid most of the wind. Well, there's some crap there. Flight level 390. Right now, I've fetched everything at 340. What's my flight plan actually tracking as? Let's have a look at very long distance. Taffy, GDM. So what's the wind at Taffy? So this is the Atlantic crossing. 265 at 30. 306.17. Taffy is 186 at 18. Huh? That true? Let's analyze this because I don't trust it. Taffy is, oh, right, yeah, that actually would make sense. Yeah, we kind of avoided all of it. If I plot in Janjo, yeah, we somehow avoided a lot of the wind. I mean, there's some portion here that we might actually pass through, but because we don't have any waypoints there, it didn't see that there's a burst of wind here in the middle. And so if we jump back here, go to previous 56, 5730 north, 5740 north, 5650 north. Yeah, in fact, I can sort of believe it now that it, funnily enough, with real world waypoints, with real world winds in there, we could actually be getting a bit of a boost here. Actually, hang on, do I have a window for that? I think I do, yeah. Yeah, you can sort of you can sort of see that we will be getting a boost from the wind, somewhat a kick in the back. It would be, yeah, pretty much. All color me surprised. Oh well. I guess that kind of explains why we didn't actually lose fuel. But theoretically, 4 million waypoints over Europe, 4 million waypoints, more waypoints over North America. Yeah, I mean, that's what you get with yeah, that sometimes does happen. It's just unnecessarily there's a truckload of airways here being taken over northwestern Europe, so it just does a lot of these little pieces here just get expanded into tons and tons and tons of waypoints. Funny stories, you can see how the screen orientation changes with respect to north. You can see it basically renders like a frame sort of just around the outer edge of the screen here, just outside of it. So as you scroll past the north, so basically you can see the north is over there. It sort of twists around the north point there. Obviously, if we were in the southern hemisphere, it would do the opposite. So theoretically, given that we'd be getting a bit of a boost here from the wind, we could go even faster. We could go into perf init, perf vnav, and watch the fuel value here, 2750. We could go Mach 7. Could we go Mach 0.80? That's a tall order. That's a lot of fuel. Hang on, I put in the climb here. Oh, wrong phase. Execute. Nah, Mach 0.80 is too costly. Mach 0.78 is doable, I'm pretty sure. Now keep in mind, though, that this assumes that we'd be able to get up to flight level 360 right away, which might not be possible. If we were going flight level 340 initially, or, well, this is going to assume the whole way. Yeah, 340 is too low. But if we average 360 over the course of the flight plan, we might be able to. Now, what is LRC? Yeah, I got to implement these. So these are long-range cruise speed mode, and max cruise will be maximum speed. I haven't gotten to implement those yet. Those are give your basically pre-tabulated cruise speed data. But yeah, Mach 0.78 is doable on the flight plan here. But keep in mind, yeah, just about 3,500 nautical miles. And unfortunately, we got a bit of a tailwind boost, so 4,000 miles in the Challenger is doable, but you're looking at, first of all, getting maximum fuel load in, which is about 20,000 pounds, which might depend on your ambient temperature conditions and what sort of weight of fuel you have. Really calculating the real plane. Is really calculating real fuel? Airplane fuel remaining that fast? I don't know. Could be, might not be. I'm not trying to emulate every piece of the airplane, how it works. Yeah, 19,600, that's sort of more realistic. Anyway. We could actually try and see how much fuel we do get into the airplane. Call the fueler here. And tell him to start the pump. Refuel interior. And open them up. And let's go. See how much we can get in. But yeah, 7 hours. 8 hours of flying time. So 4,000 miles. I guess there's enough. Thanks for simmers to be impatient about without slowing down a processor in the FMS to 386 speeds. I mean, the thing is reasonably quick. There are things that are slow, but I'm not sure exactly how long it would take for it to compute a new destination fuel. I do it every about 1 second, basically, when the flight plan is recomputed and reconverged. But there are details that are sort of difficult to simulate. The speed of a virtual CPU is one of them, to be exact. $1,000 worth of fuel already in the thing. 96 gallons a minute. And the wings are now full. When it's pumping 196 below 100 gallons a minute, that means the wings are now closed. Yeah, the wings have reached their high level. I mean, you don't simulate flipping bits. Yeah, no, I don't. Yeah. Totally unflyable. Yeah, literally unflyable. Where are you? Yeah, there you are. By the way, you can center the map on anything you want. So if you say wanted to center it on anything that is basically a database entry possible, you can center it on there. So we can go over to Canada. We can go over to CYVR, Vancouver. We can slew the map over anywhere. Or just, jump to whatever part of the waypoint or flight plan you want. And wrong. Format button. That's the format button I wanted to push. It's ECC like his PC. Yeah. I don't fly without ECC in my computer. Do you? So yeah, still running, pumping and pumping and pumping. 400 gallons already. £2,500, $2,500. 95 gallons a minute. And yes, you saw that right. It actually slows down as you come up to a higher tankage level because of hydrostatic pressure differential. The pump from the truck provides essentially a certain amount of what they call head pressure, right? So a certain amount of pumping capability, and as the fuel level in the tanks gets higher and slowly higher, that head pressure gets smaller and smaller. Essentially, the difference between the pump outlet pressure and the hydrostatic pressure, basically the fuel wanted to flow back into the tanker there. So yeah, when you look at refuel, defuel, it provides essentially a constant PSID, but the height of these tanks as they're filling up is changing. So this is actually going to slowly come down. Now obviously when one of the tanks closes, when one of the tank valves closes, then obviously that's going to slow down the transfer a lot. So say for instance when the aux tank here reaches full, which is still a couple thousand pounds away, when the aux tank reaches full, it's going to close up, and that's going to slow this down way faster, way much more than just a couple of gallons a minute. That's going to, you know, tail is going to be about 25 gallons a minute tail refuel, because that is the slowest line by design, sort of, so to speak. So this guy gets fuel last. Because he's got the longest line and actually the narrowest line of them all. %99.7% full on the left, 97.4 on the right. About 17 gallons of differential between them. About 120 pounds. Still pumping. Let's have a look at some more datalink crap. So we've played around with that. Did I actually go to the secondary flight plan here? Hang on, route menu, flight plan recall. Yeah. So to make it display the primary flight plan again, you gotta basically jump out of there. Hang on, if I go to here, that doesn't update it. Route menu, flight plan recall. Yeah, okay, yeah. Yeah, currently my secondary flight plan has got nothing to do with my primary. So, now funny story, this is something that the real thing does. If you copy the active flight plan, it basically locks up your keyboard input for a few seconds. So if I go like this, now, not fine. It actually did it pretty quick this time. Copy active. Now if I try and access anything different, you saw that for a few seconds there, it basically was completely busy copying the active flight plan over to the secondary one. So sec flight plan, go away. Still pumping. 94 gallons a minute now. Slightly slowed down. 55 or 54 waypoints. All of them in Europe. Almost all of them. There, at about the 10th page, we finally break through the Atlantic. Yeah, pretty much that's where we exit. Local control, I guess. . Yeah, let's do a short flight. How about that? To wrap up the stream. Ideas for a city pair that's about an hour away from each other. Any suggestions? AORDL, STL. We could. Did you pick something that's a little bit more realistic for a business jet? Because O'Hare, you'd probably be departing like Milwaukee or something like that. EDDF LSGS. That's a good choice. BYOW. Toronto Pearson. Something to Skiathos. That sounds like a bizjet trip, sure. LGSK. Fun sun destination. LGSK, sure. And from where? LSZS, Samadon Airport. Number 1 in the Alps. For LGIR. So should we be flying to Skiathos or from Skiathos? Man, this refuel is taking forever. And still refueling. Skiathos might be more fun. Nice approach. Okay, LGSK. So what sort of funny approaches you got there? Fun ones. It's just a bunch of VORs. Essentially, it looks like locator. Skiathos only had locator approaches. That seems. I'd love something that gives the FMS a workout. LGIR. Heraklion. That's interesting. Or a pretzel. That's a missed approach. EOR Bravo, locator DME. And you set LSZS. From a piloting point of view, in terms of FMS workout, not sure. Yeah, I mean, you could test my skills, but really important part is making sure that this thing works for you. There, you see, he's just closed off the center fuel tank. It's reached full. Now all we get is just going into the tail there. FMS workout. Well, LSZS has, or that looks somewhat fun. Sure, why not? LSZS, and from where? There is an RNAV approach that is kind of interesting. Aspen is a nice sit involving the back course. That's LOWW. So Vienna, do you have interesting SIDs? I believe you kind of do, sorta. Yeah, these are fun. Do an overview. So if we go from Vienna to Samadan, give me a route here. ABC123 low to LSZS. We'll take the Challenger 304 to Soville. And what's the Soville SID look like? Soville 2B. Yeah, sure, whatever. Close enough. So generate OFP. Let's quickly reposition to Vienna. Vienna, I think there's like a business ramp up here somewhere. Something like that. Let me have a look at the airport. If we had any info. So none of these guys. Sure, I guess. Where would you park as a private operator? These are all just labeled like, I don't know, very top left. Okay. Okay, cool. Thank you. Awesome. Let's get this on the way then. Underway. We won't have to refuel because as default when the plane loads, I've got enough fuel for this kind of a flight, no issues. So let's go ahead and get that organized. Bring up the joystick. Stick of much joy. So I guess this here. Huh. Yeah, sure. It looks pretty businessy. Not even very far from a runway. I still got real weather enabled. So, rock and roll. So we're not going to simulate we got ground power because normally you wouldn't have. Okay. And do our regular checks here. Fired system test.
Jet pipe overheat.
And we got all fails. Good stuff. Do the APU bottle test and get that implemented. Okay. And also the fire monitor test that also needs to be implemented. Anyway. It is the APU cranking. Alrighty. It's going to be available momentarily. And there it is. Yeah, still got the... This thing didn't quite deinitialize itself correctly, did it? Tail refuel shutoff valve open. Okay. Power you up. And close. Good. I still got the truckloads of fuel on. Yeah, we're gonna have to remove that because that is not gonna work. CL650 fuel tanks. And 0 in here. Zero in the tail. And in both saddle tanks. There we go. Sort of normalize. That the exterior 3D model for, well, it's mostly there. And for the stuff that you see here, it's mostly in place. The way it's supposed to look like, but there's a lot of little details that are missing. Good stuff. So we got power. Probably throw that on. We'll fire up the hydraulics here. Put the brakes on. Whoa. Part kind of close. Anyway, I don't need you for the moment. And what I do want is to get myself a flight plan here. So, go to index route menu, flight plan recall. Should have VDL mode 2 data link here, so that'll be quick. Ooh, we got data link. Not yet. So technical link status. What sim brief altitude do we get? Flight level 360. Data link flight plan loaded. Good stuff. Secondary flight plan. Activate. And my departure was Soville to Bree. So depart. And what runway should we get here? Looking at the departure, should probably be, let's see. Let's have a look at it like that. Soville to be, where are you? To be, there you are. We can actually quickly fetch the current weather. So give me weather terminal for low. So winds are out of the south 6. So essentially either one of the, actually the one that, yeah, the, what's the runway number again? There. That's runway 11 would work. Runway 16 would work. Runway 11 would be preferable for us in this at this time. So go to depart arrive. Runway 11. That's a lot of SIDs. Maybe they planned a different SID for us. Soville 1 Alpha will do better. It'll be better for us so we don't spend too much time on the ground there. So, hide all up. Sweet. We get an arrival. Nah, we didn't. Good. So execute that. Put a perf in it for, because I'm lazy, I'm just going to resync the fuel to our sense state. Level 3604 are en route. Good stuff. I'm going to switch you over and to EPOS display. Still aligning, so it doesn't show the terrain map at this time. We should be aligned pretty soon. And we can do a flight plan wind update. Get me some winds. Sure, looks good. And rock and roll. Perfect. Let's have a look at our VNAV setup here. We're gonna go fast, so 300 in a cruise, 300 in descent. Looks fine to me. Transition altitude, you don't really need to worry about too much. Good stuff. In fact, I'm gonna use you for data links, so you over here. Come and grab, show me your terminal weather here. UNH was 1009. And yes, you can have it synced up, so you can sync up your altimeter if you want between the left and right sides. I don't care though. Cool. You'd be talking to ATC right now, getting your clearances and everything. So for the time being, I'm just gonna say we're gonna go up to 5K. I'm gonna set my initial speed constraint here of 205, which is what the chart says, max 205 and turn there. Let me check. Deauville 1 Alpha. And it's coded in the leg here. Whiskey India, Whiskey 100, max 205. I'm gonna keep it there. Good stuff. We can enable VNAV, we can arm LNAV. And let's go ahead and punch it into takeoff mode. It won't actually make a difference currently because 112 is the runway heading, I think. Won't make a difference currently because we are on GPS data, so it won't do a runway update, which is good. That'd be bad. It did. How did it align for us? Just a quick check here. Perfection. Minimum heading misalignment. Perfect stuff. So we got the parking brake set. Let's throw in some sort of a code there. So go to tune, punch in a code or something. Okey-doke. Actually, I should have had the packs on here. Cabin is hot as hell. 43 degrees. Get both of them on. Rock and roll. Beacon on. Do you call clear prop? I don't know. What happens if you try to start both engines? Well, it'll try and crank both of them, but the APU does not provide enough bleed to actually get them both up to self-sustaining RPM. So you'll basically be burning them up at very high ITTs and very few RPMs. Alrighty, both of them started. So these guys are gonna come on. Bleeds are gonna come on this, this, and that. Okay, ready for taxi. Gonna quickly put my... Alright, I gotta turn on the trims here. Put the trim up a little bit higher. Fire up the transponder and TCAS. And let's rock and roll. We can actually turn on that guy as well. Let's go. The FMS takes a screenshot. Perhaps. Yeah. Okay, so we got taxi light on. All the other crap is looking good. Yes, we are on AP bleed for the time being. So brakes off. Actually brakes. Parking brake off. And we're gonna get run over. Probably have like a taxi chart on or something. Either Quebec or Papa here. I don't know, probably left. Just taking a shitty guess here. Yeah, should be Papa 1. Yeah, okay, that sort of matches with what I think should be happening. Means we could take off right here, A11. Alright, I didn't do a takeoff perf plan here. What's the OAT again? 21. I need a co-pilot here. $21. That initializes auto throttle. We'll go straight through, ultra the runway. Alpha 11, yeah, runway 11. Good stuff. Just gonna do this. Take off. Runway 11. Leads are off. Thrust reversers both. Send it. What the hell's wrong? Good stuff. All the other stuff I'm happy about. There was a checkbox to disable it, yeah. Anti-collision, lighty lights. We got transponder on. Let's just go. I'm gonna bring the range down a bit. Don't seem to be. We're not gonna be killed on final. That's a plus. I have a brake button only, so that's why it's sort of bobbing. Yeah. Everything checks out. Rock and roll. Takeoff config okay. Let's go. Looking for 91 point something percent. 91.5. Good stuff. Trust set. P1, rotate. Rotate into takeoff queue there. Gear up. LNAV. Because I'm a lazy bastard. Autopilot on. 180, so we're above target speed. Flaps are coming up. Put the lights over to pulse. There we go. It's holding 205. I'm gonna go flight level change here. And I'll be talking of departure at this point probably. Let's go ahead and clear ourselves up to our final altitude right away because I'm a lazy bastard. Okay. As soon as we finish that turn, I'm going to hand over speed control back to VNAV. That'll be push twice and then just push resume VNAV. Resume 250, VNAV plan speed. Get rid of this now. Well aligned. There we go. So resume VNAV speed. It's gonna dip down a little bit. Lower the nose and pick the speed up. I should have had the smoking and these guys on. Okay. Coming up on 10K. So we'll start the transition over to engine bleeds. So this comes off, this comes on. We should still have a climb. And this comes off, and this comes on. Good stuff. Bleed is good. APU gen off. APU off. And we are above 10K, so pulse lights are coming away. I don't need them anymore. Okie doke. And we'll head on over to standard pressure as well. It's going to maintain 270 until Mach 0.77, then it's going to switch over to Mach mode. Good stuff. We managed even not to run into any traffic, so that's helpful, because obviously there's none currently. Predicted top of climb is after Sowville. Currently at our present climb rate, we'd be ahead of Sowville, but that's going to shallow out as we climb up higher. This APR arm is automatically going to go away after 5 minutes, so you don't need to do anything about it. All you got to do here is, we're already in climb power mode. Good stuff. I didn't download. No, I didn't. Sweet. And yeah, that's it. Nothing much more left to do. Then wait, I guess plan our descent and something. 25 knots was our prediction here. Leg wind. Yep, so we'll pretty much something knots. 20 knots here, 21 there. Probably you're climbing a little bit steeper than I'd expected. Maybe not. Really just depends on whatever winds X-plane gives us. I don't manipulate the winds based on the atmospheric model that I have here, just the temperature. Tropo is up here. Actually, we're going to be a little bit hotter than the minimum temperature with tropopause when we get up there. Yeah, the wind prediction is about 20 knots, not quite 30. X-plane's giving me 30. Whatever. Whatever you say, Mr. X-plane. And I'm going to remove terrain display because it obviously doesn't apply at this point. Let's quiet you down a little bit. Take the edge off of it. I hope it's not bleeding through my mic or something. That'd be bad. It did. Let's play around some more with datalink. Winds aloft at Soval. We can see, since we are now in flight, I can show you how datalink performs in the air. So VHF datalink, and you can see these are all the beacons that we can currently see. And wait for the station refresh here. Which hopefully is going to happen soon. There you are. But currently we're still locked into Vienna, minus 81 dB, but operating at a fairly high bit rate of 22k bits. And we got Linz here. Graz. Miles away. 300 miles is essentially the distance limit beyond which I don't simulate stations being receivable at all. Perhaps I should. I don't know. Maybe more like 350. I don't remember what the limit is anymore. Dresden. Minus 100 dB. Yes, that's exactly it. So it's the type of station that you're looking at. Blue ones are VDL mode 2, which I can show you what it is. So, VHF datalink mode 2. So if I didn't break anything. It's this thing. Or more accurately, VDL mode 2. Go to Wikipedia. But bring up signal wiki. No, not that one either. Wiki. There we go. IKO VDL mode 2. So that. And the opposite of that, or the black ones that you see here, are, it's sometimes called VDL mode A. Yeah, 8PSK. That was state of the art back then, dude. Sometimes referred to as VDL mode A. VDL mode A versus VDL mode 2. Well, it's not really an official VDL mode. So it's just sort of shorthand referred to it, but really what it is, it's analog. So the difference being that in VDL mode 2, the radio itself, the VHF COM radio, has to be capable of doing it, functioning as the modem. So in that case, the CMU. So when you're talking about, when we're chatting, when the radios are functioning over VDL mode 2, not receive messages. I want to go to technical. I guess link status would have worked as well. AOC corporate link status. When we're when the radio is AOA COM, means that we're running the ACARS protocol over VDL mode 2. The ACARS analog mode, in that case, was running where the CMU itself had a modem in it, and it basically beeped and booped over the COM link, essentially over the internal, wiring in the aircraft into an analog radio, and it would essentially simulate. It was practically limited to about 4 kilohertz bandwidth, really, for many of these radios for what it could do. That's why the speed is so low. In case of VDL mode 2, VDL mode 2 is the radio itself, not the CMU, but the radio in the radio rack, has digital data link capability, and that lets it run at up to 25 kilohertz channel bandwidth, which normally a classical, analog intercom would not be able to handle. Otherwise, you'd be able to hear the thing like as if you were, talking over CD or something, CD quality nearly. So that lets you use all 25 kilohertz of bandwidth, and that lets it also, thanks to the more efficient channel modulations, lets you run up to 31.5 kilobits per second. Although right now we're running at about, maybe 15, 16 kilobits per second. Right now we're simulating because of the low signal intensity. But the signal bandwidth does not, the signal bandwidth is not constant. It depends on disturbances in the channel and everything. And as soon as we level off here, it'll go into Mach 0.80. There we go. It's just walked over to Mach 0.80. And it's starting to accelerate a bit too early. Nose up. It shouldn't have accelerated yet, though. Huh. Weird. Oh yeah, we were just about past Soval as we level off here. If it hadn't done that sort of early level off there, it would have done that. Need to investigate that. VLS cap. Should have waited for VLS cap before it started the acceleration there. Anyway, so VDL mode 2 requires a digital radio that is able to basically utilize all the 25 kilohertz of the channel bandwidth. Still running off of being a minus 90 dB. Now there are more powerful stations closer in at this point, you know, by 4 dBs, but in order not to interrupt the link or not retune too frequently, the radio will only swap if there's a sufficient delta between whatever the... by the way, this list is sorted in preference of linking. So when the radio, whenever the CMU thinks that this is a more preferential radio station to link up in, it's sorted higher. And before it swaps away from what's currently solidly outlined, that's the one we're currently locked onto. Locked station. Next station is still wants to lock onto the same one, and when it thinks that there's a sufficient signal difference between them, I think 5 dB should be pretty close to getting to a swap. Then this will, the top one, best one, will go a dashed outline. It'll say next station to the other one, and after it's locked onto the other one, it'll basically drop the lock to the old one. It basically minimize signal interruption if you're currently transferring data. And take a couple of seconds to do a signal swap. I should have tried a swap already. I don't remember anymore what the thresholds are. Still, 91 dBs is perfectly serviceable. Usually does it when I'm not looking. When I'm looking at it, it never does. And just when I look away to do something different, there it is. There it goes. See? Dash, dash, dashed. Trying to lock onto the new station, and there, it's just swapped. And it's boosted our bit rate by about 4 kilobits. We went from about 14 kilobits max to about 20. So I guess 6 kilobits, I guess. So this is channel max transfer rate. This is really a kind of simulation, simism, I guess. Now, Linz is a lower power transmitter, so it's only about a 20 watt transmitter. Vienna's 40 watts. Ross is also 40 watts. Let's see what it's going to lock onto next. There's Ljubljana. That one I don't know what that is. BLQ. Probably something in Venice. So... Florence. What are the other ones? I don't know. You guys know better than me. But while we're here in cruise, I'm going to take a quick pee break. And I'll be back in 5 minutes, folks. Don't go anywhere. Alrighty, back in the saddle. Okay. Quick discussion about decibel values, I guess. Gonna have to be a very quick discussion because we only got 80 miles to go to the top of descent there. So how do these numbers here work, right? 89 dB, whatever dB. What is a dB of a dB of what? And so the way that this works really is that this is an expression relative to a certain reference value, right? So this is a logarithmic value, log. What does that mean? This basically means when it says minus 90 dB, that means it is 10 to the power of minus 9.0 times strength or signal intensity versus some reference value. When it says dB here, that's kind of a shorthand really. The full description is its decibel milliwatt. So this is essentially telling you how many milliwatts of signal power the radio is receiving. So it's receiving currently minus 90 dB decibel milliwatts of power versus 1 milliwatt, which is the reference value. That'll be 0 dBs. The transmitting station is transmitting 40 watts. So it is transmitting 40,000 milliwatts. Expressed as a decibel value, that would be 46 dB. So it's transmitting, this guy is transmitting at approximately plus 46 dB at the station. That would be sort of what you would measure if you were, one reference distance unit from the station, I guess, or if you could capture the entire energy of the station. Back here where we are, it is being received at a signal intensity of minus 91 dB. So compared to, so we were 46 plus minus 91, so 46 plus 91 is 137 dBs of signal drop off between the transmitter, or when that's in this case lens here would be minus 91, but let's look a little down here. 137. That means it has dropped by 13.7 orders of magnitude of signal power. So how much is that, you might ask? We can do a quick bit of math here. So it has dropped by a factor of approximately this much. So 1,000, million, billion, trillion, 10 trillion times less powerful is what we're receiving here. Or if you were to divide 40 by that number, that means that we are receiving, what would that be? Nano would be 9, micro, nano, well, about, give or take, probably about 1 picowatt. Yes. So we are receiving about 1 picowatt of radio transmission power from that station. That is the signal intensity that the aircraft is seeing currently from Ljubljana compared to what its transmitting power was. Oh, it's switched over to Munich. So about like that. Let's have a look. Let's go ahead and pick up terminal weather at what's our destination again? I forgot. I shouldn't do that. Shouldn't be forgetting. LSZS. Go ahead and fetch. So, weather variable, good, scattered 4200, basically not a problem for any approach. Broken 5.5, that's not a big deal. 1016, temperatures plus 9. Are you flying quite heavy, close to some limits? Yeah, probably we are. We're actually going to check. So, perf, approach. Let's see, what's the runway? What are the runways there? Samadan, what are your runway names? I just got to punch in one of them, or just a runway length reading. Runway, let's say, whatever, 21, doesn't matter. It's RW21, runway ID. And plus 8 degrees Celsius, or plus 9 actually. Computed runway length. Actual runway length, actual landing distance is 3144 feet. Landing field balanced length is, or a landing field factor of 40% extra is 5,200 feet, or this many meters, 1596, 1,600 meters. So we should be good. In fact, runway 03 gives us a little bit more. Yeah, 1843, that's the one you mean. So we should be good. 1,600 meters is what we'll need. Actually, that's balanced field length. Actual landing distance, 950. We go and put in an extra 20%, 1150. And that is given our... Did I reset the gross weight here? Okay, yeah, we've got essentially 0 weight on board, so it's just fuel. Yeah, we should be good. EDU2 go away. Good stuff. So let's plan an approach quickly. RMP21 is the one I wanted. Now hang on. With that. Yeah. Oh, I was hoping for something better. Oh, we'll do a visual approach. Yeah, sure. With RMP guidance 03. Good stuff. Actually, yeah, that's the one we'll do. So depart, arrive, RNAV RMP3 from Palad. Or have a look at it. What does it look like? Switch you over into plan mode, bring the range down a little bit. Ronak, Pelad. Yeah, sure, we'll just go after Ronak's direct Pelad. Like that. How about like this? That looks sort of convincing to me. How are we looking in terms of top of descent? That has pushed it way out. We still got about 80 miles to go because of the extra track miles that we're going to get there. What is the final descent angle? 4.5 degrees. I know why you picked it. The aircraft constantly communicating with the station, or only when requesting and receiving data? Only when it's requesting and receiving. Otherwise, it's generally quiet. So you'd see an outbound message when it says VHF in progress there. We could do a flight plan wind update if we wanted to for the remaining part of the trip. So flight plan wind update. Send. Probably not going to make a difference, but you can get at least the rest of the winds all the way down to the ground or whatever. Datalink flight plan winds are updated. Or execute the change. Yeah, so currently expecting 40 knots or something. 270 at 41. We're measuring 38. Keep in mind, this might be variation because of how X-Plane gives us weather. And also because of how the INSs might be slightly measuring it incorrectly. These guys do have a limitation on accuracy. Though generally they're pretty accurate. Gentle turn there. No need to sweat. It's only 15 degrees of delta or track change, so just banks a little bit there. And just does the ever slightest bank it can. Inmarsat next? Yes, sir. We get coverage over the ocean. Yeah, so the aircraft only talks to the systems, the ground systems, when it needs to. So if we had some scheduled, reporting and that kind of stuff, it would talk a little bit more frequently. But for example, right now it's going to say that it can't fetch data ATIS. The best we can do is get a terminal weather report. METAR tap, no PIREPs. Still variable 1, 10K, 4, broken 4.7, so the ceilings are 4.7, give or take. Report was made at, it's 21:46, so 19:46, yeah, it's about 20 minutes ago, 30 minutes ago, so there should be a new one soon. Yeah, this is it basically at this point. Info about how the bandwidth of the channel is calculated. So that's basically just using the signal intensity, the instantaneous signal intensity. The real thing doesn't know channel bandwidth unless it tries to communicate. So this is really showing for your purposes, for my debug purposes, to know what we could do. The actual channel bandwidth adapts based on signal loss. So basically the aircraft tries to talk as fast as it can, and if it sees a lot of drop packets, it basically backs off on the speeds until it can get through something. So that's how. I don't consider these to be, numbers. This is not 100% a representation of how it would work. The reality is I just don't have enough data for everything, obviously. Is this Samadan there? No, so the reason is because these guys are sitting on a different frequency. So these guys are in the Northern European, I guess, or whatever. Europe set a network in Europe has two frequencies, so I'm sort of separating them out, where half of them are sort of in the E portion of the ARINC or the ICAO codes, and the other half are in the L codes, so they're lower, I guess, half of Europe. We're tuned to one of the northern stations, so it sees beacons from all these guys all the time, or not. It doesn't see beacons from all of them. For some of these are too far away to receive beacons from, but this is a display of what the nearest stations are based on essentially the distance measuring system. And it's not a part of the aircraft, that's part of the simulation. And you'll see occasionally a bunch of stations light up down here. Those are coming up when the scanner here passes through the frequency of one of the other ones that currently aren't tuned in, or sorry, the L ones. So you'll see the other ones light up here momentarily. There they go. Some of them, and there might be more. W99 90. That's Geneva. 200 miles away. Loading terrain to Geneva. Not right now, it's already tuned away from it. It's not going to load in. This is Stuttgart. Ah, there they are. So right now this is past the tuning system. Has currently tuned in these other stations, so that's why it sees them. And it gathers up all the beacons for the guys. The radio is basically gathering up the beacons for the ones that are currently tuned in. Now it's tuned onto another frequency and it's testing there, looking on that one. Currently though, Munich is the best one we've got. Airing, oh, you mean like airing the data provider? Oh, no, they do have plenty of links here. They should anyway. Or maybe not. I don't know. SETA is somewhat better built out in Europe. Airing has more stations in the US. But they both have stations all over the world, so if one is not available and the other one is, the aircraft will sort of roam onto the other network if it can get that. There's something else I wanted to test here. I forgot what though. Oh, this is ES. I have new weather now. Maybe. Turn on the weather request. Yes, please. Yeah, fresh weather. Right, winds are out of the northeast, so that's good for runway 03. Light drizzle. And ceilings are coming down. And we should start our descent soon, so there we go. I'm going to roll down the pre-selector. Pilots are aware of which station the aircraft is tuned. I mean, you can look at it, but generally you don't care. Generally it says only data mode here. But you can check it if you go up here into exit, return. And if you go to datalink menu, link status, you'll see what the frequency is actually tuned in, but you don't manually tune it. It does it automatically. 5 seconds to top of descent. There we go, VPath has engaged. Good stuff. Not much we can see. Keep on rolling it down here. That's our minimum here. This might actually not be usable. Whatever, I'll change the weather if need be. These continuous descent to final approach speed. Half bank selected. What? Why are you unhappy about that? Or it's probably because, right, we're getting close to the approach. I'll deselect your halfback. There you go. Check our port OAT. Yeah, so come in here. Temperature comp +9. Okay, I'm not going to do that then. Cancel. Cancel. Yeah, okay. Disable temperature compensation. Turn to slow down here. There's going to be a speed constrained palad. Yeah, there's a visual portion there. Whatever, we'll sort of eyeball it. I honestly don't care enough to reprogram it for a different approach. I could. Looking for something with a little bit of, you know, I guess chest hair, you could say, but this thing doesn't really have too many interesting ones. Poor choice of airport, but whatever. Roll with it. Okay, weather, view terminal, weather, QNH 1017, so we'll pre-select that. 1017, 1017. Bring up the HUD. Really hard to see a green HUD over bright sky. You show the timing in the plugin admin. Sure, there you go. Good enough? The HUD will cost me a few milliseconds or a few microseconds. Yeah, there we go. About 0.1 milliseconds. 0.2 maybe for the HUD. And each of these pop-ups costs a little bit. If I turn off the synthetic vision here, it's going to go even lower. There you go. That's without synthetic vision. And I kind of do harp on a lot about, you know, having low overhead. Yeah, so coming together. Palad there for 240, so we're gonna have to give it a bunch of speed brake here because at this altitude slowing down below 250 is kind of hard. My 28 frames here are mostly caused by the clouds because my GPU and its CPU is melting. Well, it's mostly GPU melting itself. It's a piece of trash. Also running streaming and everything. There we go, mostly at 240. Next speed constraint is 160 at ZS 0701. That was if they ever wanted advanced systems on high performance. Yeah. Unfortunately, that is not for me to decide. Yeah, there we go. Now you can see the VNAV window showing stuff. 3 degrees ZS702. 18 or above. 11.8 or above. Can we engage approach mode here? RMP arm. Yeah, at these kinds of low speeds and high altitudes, it's getting really hard to slow down. Lost the vertical profile here for some reason. No V-path cross-track. You shouldn't have reported a cross-track violation there. Log page. 400, 500 feet high. I'll get some flaps out, that'll slow us right down. Get those butts in those seats. Pretty crazy kind of maneuver in here on the approach here. Down to 160. Don't seem to have previous programming experience. Yeah, that's one of the reasons probably why. Anyway, swap over to local barometer there. We should be reeling it back in. There we go. Since we're on the approach now, the scaling here is 250 feet, so that's why it's still off scale, but as it comes below 250, yeah, there it comes. Gonna bring up the HUD here. Okay, V-path capture. Does this thing even have a final approach segment? Hopefully. Into the soup we go. Get the pulse lights on. In fact, we'll fire up the APU now. Start transitioning them back onto the APU. As someone who knows nothing about explain development, how can I imagine the architecture of the simulator? Like, does everything run inside of the simulator, or do you run stuff out? So it's just it's complicated. I'll get to your question, Nick, here in just a sec. Not an entirely wrong impression that you've got there, but there's a few details I'll fill in later on. when we're not approaching. Nice. Ah. Also turn on the wing anti-ice. That's a surprise. Forgot I even coded that. There we go, we're on VGP mode now. What's the missed approach? 14K. We should now be starting to do a visual here from ZS7 or something. Okay, wing and cal anti-ice are heated up, or hot. Yep. Feature is something straight up won't fix. About some Intel FX, I'll get it done. It's not a problem. It's more a matter of like prioritizing. They have a somewhat weird method of doing everything. Okay, actually, so index, no, perf, approach. I did want to send you your F-130.
2500.
And I'll bring in rain, I guess. I'll put it on the map there. Yeah, sure.
2500.
You sort of point it at the correct thing. Is the runway much closer? Never mind that little nugget there. That's a piece of stray geometry we'll get rid of eventually. Okay, we're sort of pointing at the right thing there in the synthetic vision. I can see. So I'll take over manual speed control here. We're getting there. 6 miles. Throw some gear down. Arm reverse. Auto brakes. Auto brakes aren't a thing here. Ground spoilers are armed. Okay, APU is ready to go, so we'll transition over our packs. Kill the anti-ice here. We'll see that the temperatures on the engines are going to come right down. Good stuff. Keeps the speed coming back to about 5 knots above VREF. Got fairly little wind there, so final set of flaps there. Alrighty. He's ready to land. do the piloting thing. Flight directors are coming off. And let's just do a land in there. No, not a problem, huh? Swing it over.
1,000.
When we get close. Got the runway in sight there. Didn't quite make out a Pappy there. Ah, there it is. 2 whites, 2 reds. All good. Three reds.
$100. 50, 40, 30, 20, 10.
Here we are. It actually wasn't quite butter. It was fairly actually rough. I did that on purpose. I didn't want to delay. I'll have to turn around here. No, there is a taxiway. Such as it is. Let's take the last one there. I forgot to turn the lights over on too. Solid on. We had them on pulse the whole way through, but whatever. As long as something was on. You'll be landing much better than I. Yay. Lights, lights, lights. Wow, these guys are narrow. Yeah, I kind of planted it on there. I didn't want to float because I knew I didn't have too much runway to play with, so. Okay. Reversers, or the speed brakes in. Reversers are disarmed. Good stuff. And the standard Challenger problem with the thing accelerating on its own down the path here. That icing message honestly kind of caught me off off my, or off guard, I guess, because I didn't expect it. These guys can come off. We're looking for a runway cross here. We're sort of a beam control tower. And again, we're full idle and the thing just wants to accelerate, keep on going faster and faster. Classic Challenger of life. And mind you, I'm still got quite a bunch of fuel on board. Still wants to accelerate, and 5,500 feet above sea level, and yet it wants to accelerate. Down at sea level, it wants to accelerate even harder. And don't let it fool you that the nose is down, that means we're going downhill. No, the Challenger's nose is down all the time when it's on the ground. There's a cop car there. They're ready to come to arrest me or something. Up the buckets. Yeah, theoretically you could. Is there gonna be a taxiway here? It should be. Oh, there it is. Feels like I've landed on a service road, but it's marked as a taxiway. Like, or I'm taxiing on a service road. Okay, it's just stupid markings by somebody who didn't know how to make airports. They got solid yellow lines here. So, got the strobes back on. Check left and right and all the good stuff. I'll park in front of one of these hangars, I guess. We can get there. This dude left his truck right in the middle of the road, middle of the taxiway. Oh, there they're coming with the limo for us. Oops, I didn't want to stop here. Yeah, that's the problem when you use a button for brakes. You don't know if you're... The hell, dude? Move your stupid thing. I'm gonna turn in front of him then. I'm gonna park instead over here where I'm gonna get run over by a different truck, I'm sure. There, that guy's got my number. I already feel it in my bones. Ah, whatever. Cool. You're gonna kill me? VHF reception, what it looks like. Yeah, sure. Let me just check that. This guy gonna kill me. Yeah, he's gonna run through my wingtip. And boom, right there. Sure. VHF reception. Let's see. Yeah. It does have a station here. There is an 8-cars VHF ground station. But it's only 2.4 kilobits, so... And we're simulating it effectively as being, you know, somewhere up there. Is there wind here? Not really, no. The engine's eventually going to stop. Anyway, so quickly, just to account for or cover the last questions you guys have had there. Okay, so apparently I can scroll back in chat. Lovely stuff. And of course, old chat. Oh, there it goes. Okay, so as someone who knows nothing about X-Plane development, how can I imagine? So the architecture, call me Nick. I hope you stuck around to hear the answer. So the architecture of X-Plane essentially is, from the point of view of the plugins, X-Plane has only one thread exposed to you. So your plugin only ever is supposed to run when you get a callback from X-Plane. Turn these off. Only when you get a callback from X-Plane that you're allowed to run. So basically, X-Plane, you've got a bunch of callbacks that you can register. The primary ones for execution purposes are called the flight loop callbacks. So those guys are running whenever X-Plane executes a physics calculation of the entire world. So it integrates all the aircraft, your aircraft, aerodynamics, and sort of all the weather and everything. And then it calls your flight loop callback. And there are two phases. You can be called either before the flight loop integrates per frame or after the flight loop integrates per frame. Then you've got a bunch of draw callbacks, which are optional, which are also, I mean, all callbacks are optional. You register for them. But draw callbacks happen at various phases of composition of the simulator. The primary one that most plugins register for is drawing onto the panel here. So this panel, or not this, but this, what you see here mapped in the 3D cockpit, that is in a special piece of texture space called the panel texture. And when X-Plane calls you that you can draw into the panel texture, it automatically binds the relevant OpenGL state for you, such that you only have to draw to the default draw target, and then that's going to be mapped into the 3D space here. There's also a bunch of special draw states for things like 3D stuff. And those are a little bit complicated because of the fact that the simulator itself is running in Vulkan, whereas your plugin is only exposed to OpenGL. The reason for that is a bit complicated, but essentially, from your plugin's point of view, the simulator is single-threaded, and you get called at certain strategic intervals on the main thread to interface with the sim. In terms of data ref exchange, so anything that the simulator's API has exposed, the SDK, all of that is restricted to single-thread call only. That means exchanging data refs. That means setting data ref, invoking commands, reading and writing any kind of sim side GL state. That is all single thread or main thread only. That does not mean you cannot set up your own stuff. You can, and probably should. Thanks for driving through me. Bye bye. I hope you burn. Why would you put trucks driving on the whatever? Anyway, so that does not mean you cannot create your own threads, and in fact you can. It's just you have to synchronize your data interchange with the simulator to only those callbacks. So that's essentially what I do, is all the avionics that you see here, synthetic vision, all the drawing here, all the underlying flight management computing stuff and all that stuff takes place in completely separate threads. So that is why we can get these times here to be so low. Come on, there you go. That's why we can get these times to be so low, especially if I turn off synthetic vision here, it goes way low. The reason is that this only accounts for main thread CPU usage, but I do basically 99.9% of all the complicated stuff and time-consuming stuff is happening on background threads, which modern CPUs have, which modern multi-core CPUs have plenty of horsepower available, especially when we're talking about the Challenger's minimum config is going to be a quad-core, and a recommend is going to be a 6-core machine. But we're talking even a quad-core machine, even if the simulator is occupying a full 4 or maybe 2, you still got 50% of your horsepower available and just sitting there not doing anything. So that's what we utilize by not interlocking with the simulator here. Also lets the simulator run as fast as it can. So you can see right now it's taking about 16 milliseconds to emit a frame. Let me actually see if it's, for whatever reason, it's not even, simulator's not taking up a lot of time, and the GPU ain't fully loaded, so I don't freaking know why it's not running faster than 30 something FPS here. Potentially at full HD resolution. Could be that there's other stuff. That's basically that the GPU is bottlenecked in some other respects other than just GPU pure utilization. But anyway, point being that again, thanks. Point being that effectively the simulator from your point of view is single-threaded, and what you do other than that is up to you. So for my part, I don't currently run the avionics outside of the simulator's process context. It just makes sharing data a little easier if you're running in the same memory context. But theoretically I could. There's some stuff I do plan on doing before release. And also, if you want to exchange external data, sure you can, not a problem. Your plugins, wow, that wheel there looked like, I think it was possessed by Satan or something. If you want to do anything you want, you can do basically, because the simulator simply it's not like Microsoft Flight Sim where you're running inside of a virtual machine in a special encapsulated environment. Make sure when you call back from circuit call, you have the data from the threads ready. Yes, exactly. Essentially, so the threads. The neat thing is that real avionics also runs all asynchronously, right? So all these computers are running all their own state, and they just interlock with each other whenever there's time. So there's necessarily a certain amount of springiness, so to speak, between, for example, things like the autopilot responding and your flight controls and all that good stuff. So the autopilot doesn't have any trouble adapting for the fact that there's let's say a quarter-second delay between its commands and them actually, taking effect for the flight path of the aircraft, or more, even more than that. Oh, hi, Thune. It is very much a VM. Yes, it does boil down to an x86 subset, and it does get JIT compiled into native instructions. But the difference is you don't have the WASM environment does not give you full host API access. For example, you don't have full file system access. That's not a thing. You don't have full Win32 API access. That's not a thing. You get a very, very small subset of OS functionality carved out for you by MSFS, and that's all you get. Essentially, you get memory management. I don't think you can get WinSock or sockets. You're welcome, Kalmanik. So yeah, you don't even get like network access from WASM internally. That's why I said it's a fairly limited environment. It's not that it's impossible to code for, it just gets it is far away from that. No, I'd say it's close enough to the point where it makes no difference. VM, I mean, as in it's a container environment. It's an encapsulated environment where you cannot do anything, or you can't do many things. For instance, in X-Plane, I can touch any piece of GL state that I want. Not so in MSFS. Well, MSFS, first of all, is DirectX, but even there, you can't just do whatever the hell you want. Literally, there's no binding points for you. It just won't work. Hey, future pilot suite and interesting to speed styling back one. Most airlines roll back speed restriction directly. Is that due to VNAV integration pro lines when trying to avoid aircraft pitching up drastically to cancel speed, or no? Future pilot Sweden, that's the way. Ferrari. That is because of how the pro line, yeah, sandbox, I guess you could call it that. Yeah, that's the modern term, I guess. Containerized would be the more traditional term. Anyway, hey dude, that's an active movement area. Sure. Anyway, yeah, sandbox is a very good term for that. Future Pilot Sweden, you were asking about the VNAV, right? So that's the thing that the ProLine does. The ProLine does not do performance-based VNAV, rather it does geometric VNAV, right? So it basically computes a fixed angle of descent, which you can select manually. Well, first of all, you can punch in whatever VNAV descent angle you want. Well, let's see if it'll let me here. That's probably final approach right there, so it won't let me do it there. But you can override the descent angles here on, for example, on a descent leg. Another thing you can do, it automatically selects a descent angle, which is set over here in defaults. There we go, descent angle of 3.0 degrees. So that's the angle it expects to be. Basically, there's a reverse construction. So it starts at the runway and then draws effectively a 3-degree path all the way back to your cruise altitude. And that's where it intersects your cruise altitude. That's your top of descent point. And since this is angle-based rather than performance-based, the aircraft has no clue about, am I actually able to, for example, meet a speed constraint or do like a level off section and then continue the descent. It doesn't do that. Again, thanks. So instead what it does is when it gets close to something like a speed constraint on descent, when it starts getting closer, for example, your have a look here, your descent speed limit, right? So 250 at 10,000, it'll start rolling the speed back, and the 3-degree vertical path angle is designed in such a way that the aircraft has to keep a little bit of power on to keep the speed, basically. Otherwise, it would be probably able to do something like 3.5, but the 3 degrees is to get a true idle descent. 3 degrees is able to get you from about 300 to 250 at the 2,000 feet transition, 10,000 feet transition. You want to go, if you want to decelerate below 250 feet or 250 knots or below maybe even 270 knots at very high altitudes. That's why I had to basically pull speed brake today, because we were trying to do 240 knots at like 22,000 feet or something like that, twice as high as it's designed, or the angle is designed. So it was basically, it already was at full idle, and it struggled to get below 260 knots at like 22,000 feet. So that's why I had to pull a little bit of brake there to get the thing to basically come down and start decelerating. Once you get down, below 230 and you can roll out your first stage of flaps, you're pretty much all okay. But up until then, you basically just have your only fighting chance, or it's the aircraft's teeny tiny speed brakes, which the aircraft has. Get some hydraulics up, and the aircraft only has separate flight spoilers and ground spoilers. So here are your flight spoilers, and there are only 2 little boards on the wings, and that's it. Whereas your ground spoilers are only the inboards here, and those are only automatic, or well, more or less automatic. There's a couple of extra positions there, but essentially automatic on landing. Whereas your flight spoilers are only manual, and that's why you'll see frequently Challenger pilots, as soon as they come, as soon as they touch down, they'll pop the reversers and then immediately go to full brake. They'll reach over and literally pull the brake just to get the flight spoilers up as well. Because the ground spoilers are going to come up as soon as the gear touches down. As soon as you get gear touch down, the ground spoilers are swinging out. But these guys need manual actuation. And there's some amount of interlocking, smarts. So when you pull flight spoilers enough, even for example when you've got ground spoilers in auto and you're on the ground, when you start pulling out flight spoilers past I think the second detent here, it'll pop out the ground spoilers as well. By the way, there was a reason why the flight spoilers come out in smooth fashion and the ground spoilers are sort of on or off, and the reason is that there's a separate sensing mechanism for them. Flight spoilers have an analog position sensor, but when you roll them out, you can actually see them transition because you can put them into some intermediate position as well. The ground spoilers only have a micro switch. Literally, as soon as they come out of their fully retracted position, this automatically shows full deployment, even though they might still be transitioning up. It only takes about a second though. Normally you keep this always in auto, and that'll be all. That'll be giving you everything you need. Cool. Engines are cooling off slowly. In fact, I don't even need both packs here. I showed this earlier. When you look in Probably over, yeah. Since we landed, we got a flight log here displayed on CDU2. I'll also show on the other CDUs as well. So we were 58 minutes. We used up 2277 pounds of fuel, air distance 379, ground distance 355, and the air distance and ground distance delta is because of wind. What big tasks are on the CL to do? Feel like we're getting closer. Yeah, we're definitely within, you know, distance. I don't want to give a definite release time yet, so I won't, but this year's, it's happening this year, for sure. Motor one of the engines so we can see how quick it cools down. So what, funny story is what you're gonna see. What you're gonna see is, first of all, you're gonna see the sensor here get very cool very quickly. That's not because the engine is cool, that's because the just the airstream through the engine is cool, and there's the ITT probe is sort of stuck out, and you'll just get a bunch of cool air blowing in there. But as soon as I let go of the starter here, let me do that for you since you've asked so nicely. So there you go. See, the air cools off almost instantaneously, just gets blown out. All the hot air gets pushed out very quickly. You can see the sensor is cooling off really good. If I stop the start, report the start, it will be cooler. It won't heat up quite to the 212 at the other engine, but it won't be only 100 degrees. So it'll climb back up. So we gotta wait for the engine to really roll down. You see the temperature starting to climb back up because it's starting to heat up again. As the air is slowing down, it's starting to heat up from the surrounding environment here. And the primary reason is this guy here, basically the mid-frame and combustor. These guys are still very, very hot, so this is basically the metal structure of the engine. That's what's causing the temperature here to climb. And you can see it keeps warming up again. But it didn't heat up quite to the same level of the other engine. Because it is, after all, still a lot cooler. At this point, it's cooled off a little bit more than the other engine. But it'll keep on climbing back up a little bit. If I show you the other engine for comparison, we lost about 25 degrees in that motoring there. Ironically, the oil temp here is much higher now on the left side. Know why? Try and guess. Why is the oil temp now hotter on the cooler engine? Now, oil temp sensor is in the oil tank. Well, it's sort of, yeah, it's close to it. Yeah, exactly. We just pushed. So if we look over here on the engine we didn't motor, the oil here in the bearings and in the engine core, like 200 degrees Celsius. Hey, heli pilot, how are you doing? I'll be wrapping up the stream here momentarily, so I'm just doing a quick outro here, I guess, talking about crap. Yeah, the oil here in the bearings and in the engine core is 200 degrees. Oil in the tank here is maybe 100, and the oil temp sensor is about here where the oil pickup is out of the oil tank. So pretty much what you see passing through here is what the oil temp sensor shows. This guy now, we've sort of equalized the temperature. We pumped the hot oil mostly out of the engine, or at least the hottest part, and we dumped all the hot oil here into the oil tank and then basically recirculated the system again. So we'd see much the same if we did the same motoring on the other engine as well. But yeah, That is why you're going to have a much higher oil temp. Now the flip side is this guy's going to cool off a lot, well, not really cool off a lot faster, but the oil in the engine is not going to be all that hot, I guess. And the reason why, by the way, I turned off the other pack is you saw me do this before, but it costs fuel. We use polars to simulate blade thrusts. And the elliptic turbine sim. No. Rust. No. So, no. So it will be so elliptic turbine is not an aerodynamic simulator. It's just not practical to do an aerodynamic simulation of an engine in real time. It's just not possible. There's too many wings, too many moving parts, and to get the transonic flow through the engine anywhere right, you'd have to be doing CFD really on these blades. So that's just not practical. Instead, the behavior of the compressor is pre-calculated into what they call a compressor map. So this is what a typical compressor map looks like. And this is mostly experimentally solved or computed using CFD simulation and then experimentally verified on a real thing, on a real compressor test rig, which plots normalized mass flow rate against pressure ratio against a three-dimensional, it's essentially a four-dimensional graph, because you've got compressor constant speed lines, and then you've got, as a heat map, expressed your compressor efficiency. All of these get combined into what they call a compressor map. And yeah, that's what gives you what you don't see on here is the compressor operating line, because it can sort of vary. The compressor operating status can sort of show different, be at different points in the map here, depending on, flow conditions through the engine. So yeah, they pre-calculate that because it's just not practical to do this in real time. You'd explode. Well, you'd run at like less than 1 frame per second. We wanted to do it anywhere, in any reasonable way. And the reason I turned off the other pack is because it costs fuel to run the other pack. About 20 pounds an hour, maybe 30. But yeah, 30 pounds an hour to run both packs. And one pack is perfectly sufficient to run the air conditioning on the ground here. Cool. I gotta wrap it up here, folks. I hope to see you soon, you in Discord and all that good stuff. Everybody take care. Much love. Enjoy your 4th of July. And yeah, I'll talk to you next time. Take it easy. Bye, folks.